Inputs: the email address used for creating the Azure account. For example, john.doexample.com. The password for the Azure account. It should meet Azure's password complexity requirements. Outputs: the Azure subscription associated with the newly created account. This is a unique identifier for the subscription. The Azure Tenant ID, which is a unique identifier for the organization or entity associated with the account. Steps: navigating to the Azure portal, the main web interface for managing Azure services. Clicking the Create Account button on the Azure portal homepage to initiate the account creation process. Entering the email address provided in the Inputs section. Entering the password provided in the Inputs section. Confirming the password entered in the previous step. Agreeing to the Azure Terms of Service and Privacy Policy. Completing the email verification process by clicking the verification link sent to the provided email address. Fine-tune parameters: the geographical region where the Azure account will be created and where resources will be provisioned. Example: East US. The type of Azure subscription, such as a free trial, pay-as-you-go, or an enterprise agreement. Example: pay-as-you-go. Metrics: the timestamp when the Azure account was successfully created. The status of the Azure subscription, indicating whether it is active, suspended, or expired. Visualization plots: a visual representation of the timeline of the Azure account creation process, showing the key steps and their duration. A chart or graph displaying the usage metrics of the Azure subscription, including resource consumption, cost, and other relevant data. Error analysis: an error message indicating that the provided email address is invalid or already in use. An error message indicating that the provided password does not meet Azure's complexity requirements. Challenges and fixes: if the email verification link is not received or has expired, users can resend the verification email. Resending the verification email will allow users to complete the account creation process by clicking the new verification link sent to their email address. If the account creation process fails for any reason, users can contact Azure support for assistance. Contacting Azure support provides access to expert assistance and troubleshooting guidance to resolve the account creation issue. Inputs: Azure subscription. This refers to the specific Azure account that houses the OpenAI resource and grants access to it. It's essentially the contract that allows you to utilize Azure's services, including OpenAI. OpenAI resource: this represents the specific OpenAI service or model deployed within your Azure subscription. It could be a pre-trained model like GPT-3 or your own custom-trained model. Outputs: access token. This is a temporary credential that allows your application to securely access the specified OpenAI resource. It's like a digital key that unlocks the door to the model's capabilities. Steps: authenticate Azure. This involves providing your Azure credentials, username and password or service principal to authenticate with Azure systems. It's the first step in establishing a secure connection with the Azure environment. Retrieve access token. After successfully authenticating with Azure, you'll need to retrieve a specific access token that grants permission to access the designated OpenAI resource. Think of it as getting a special pass to use the model. Prerequisites: Azure subscription. As mentioned before, having an Azure subscription is a mandatory requirement to access OpenAI services on Azure. It acts as the foundation upon which the entire process rests. OpenAI resource: you need to have an OpenAI resource already deployed in your Azure environment. This could be a pre-built model or a custom model you've trained. Fine-tune parameters: Model type. This refers to the specific type of OpenAI model you want to fine-tune. For example, it could be GPT-3 for text generation, DAL for image generation, or a specific variant like GPT 3.5 Turbo. Training data. This represents the data you'll use to fine-tune the chosen OpenAI model. It should be relevant to the desired task or domain you want the model to excel in. For example, if you want to fine-tune a model for writing marketing copy, you would provide a dataset of marketing text. Metrics. Accuracy. This metric assesses the model's ability to produce correct and relevant outputs based on the given input. It measures how well the model understands and fulfills the task at hand. Latency. This metric measures the time it takes for the model to process an input and generate an output. It's crucial for real-time applications and user experience. A lower latency means faster responses. Visualization plots. Performance charts. These charts visualize the model's performance over time, showing how it improves with training or how its accuracy fluctuates. This allows you to track progress and identify trends. Confusion matrix. This matrix provides a visual representation of the model's classification performance. It highlights the number of correct and incorrect predictions for each category, helping to diagnose specific areas where the model may be struggling. Error analysis. Model bias. This refers to any systemic error or prejudice present in the model due to biases in training data. It's important to analyze and mitigate biases to ensure fair and unbiased model outputs. Data quality. This aspect examines the accuracy, completeness, and relevance of the training data. Ensuring good data quality is crucial for model performance and prevents issues like overfitting or generating inaccurate outputs. Challenges and fixes. Challenge 1. Access denied. Fixes to Challenge 1. Verify permissions. This involves checking if your Azure account has the necessary permissions to access the specific OpenAI resource. You may need to adjust roles or permissions to grant access. Check subscription status. Ensure that your Azure subscription is active and in good standing. A suspended or expired subscription may prevent you from accessing the OpenAI resource. Challenge 2. Rate limiting. Fixes to Challenge 2. Reduce API calls if you are exceeding the allowed number of API calls per unit of time. Consider reducing the frequency of calls or batching requests together. This helps to stay within the limits and prevent throttling. Use caching mechanism. Implementing a caching mechanism can significantly improve performance by storing frequently accessed data and reducing the number of API calls. It's a common optimization technique to handle high volumes of requests. This document outlines the process of choosing the appropriate Azure OpenAI model for a given task. It considers factors such as the intended use case, the characteristics of the data, performance requirements, and budget constraints. Inputs. The specific task for which the model will be used. For instance, it could be text generation for writing creative content, translation for converting text from one language to another, or summarization for condensing large amounts of text into concise summaries. The characteristics of the data that will be used to train or interact with the model. This includes factors like the size of the dataset, the languages involved, and the specific domain or subject matter. The metrics that will be used to evaluate the model's performance. This could include metrics like accuracy for measuring the correctness of the model's outputs, fluency for assessing the readability and naturalness of generated text, and speed for evaluating the model's efficiency in processing information. The budget allocated for using the Azure OpenAI service. Different models have varying pricing structures. So it is important to consider cost effectiveness when selecting a model. Outputs. The recommended Azure OpenAI model that best suits the task requirements. Data characteristics and performance criteria. The performance metrics of the chosen model, including accuracy, fluency, and speed, which provide insights into its effectiveness. Steps. Clearly define the task for which the model will be used. Whether it's text generation, translation, summarization, code completion, or other natural language processing tasks. Analyze the characteristics of the data that will be used to train or interact with the model. This includes factors like the size of the dataset, the languages involved, and the specific domain or subject matter. Evaluate the different Azure OpenAI models available and their capabilities. Consider models like TextDaVinci 003 for creative text generation, Codex for code completion, and GPT 3.5 Turbo for general-purpose natural language processing tasks. Compare the performance and cost of different models based on the identified task requirements in data characteristics. This will involve evaluating metrics like accuracy, fluency, speed, and pricing structures. Prerequisites. An active Azure subscription is needed to access and utilize the Azure OpenAI service. The Azure OpenAI service must be enabled within the Azure subscription. This involves creating an Azure OpenAI resource and setting up the necessary configurations. Fine-tune parameters. The learning rate is a hyperparameter that controls the step size during the training process. It determines how quickly the model adapts to the training data. Epochs refer to the number of times the entire training dataset is used to update the models. Parameters during the training process. More epochs generally lead to better model performance but require more training time. Batch size specifies the number of training examples used in each iteration of the training process. Larger batch sizes can speed up training but may require more memory. Metrics. Accuracy measures the correctness of the model's outputs. For tasks like text classification or question answering, it indicates the percentage of correct predictions. Fluency refers to the naturalness and readability of the text generated by the model. It is assessed based on factors like sentence structure, grammar, and vocabulary. Speed refers to the model's efficiency in processing information. It is measured by the time it takes to generate outputs for given inputs. Visualization plots. Loss curves are graphical representations that show how the model's error rate changes during the training process. They provide insights into the learning process and can help identify potential problems. Confusion matrices are visual representations of the model's predictions for different classes. They are helpful in identifying patterns of misclassification and understanding the models. Strengths and weaknesses. Error analysis. Identify common errors that the model makes, such as incorrect predictions, grammatical mistakes, or inconsistencies in generated text. Analyze error patterns to understand the reasons behind these errors. This can involve examining the specific examples where the model failed and identifying potential biases or limitations in the training data or model architecture. Challenges and fixes. Model overfitting occurs when the model learns the training data too well and performs poorly on unseen data. Adjust regularization parameters, which add penalties for complex models to prevent overfitting. Model underfitting occurs when the model is not complex enough to capture the patterns in the training data and performs poorly on both training and unseen data. Increase training data to provide the model with more examples to learn from. Slow inference speed can make the model impractical for real-time applications. Optimize model architecture by using more efficient algorithms or reducing the size of the model. High cost can be a barrier to using the model for large-scale applications. Use a smaller model with fewer parameters, which typically have lower computational costs. Limited language support can hinder the model's usefulness for multilingual tasks. Fine-tune the model on the target language to improve its performance for that specific language. Inputs. Azure OpenAI resource. This represents the Azure OpenAI service resource within your Azure subscription, where you manage the deployment of your chosen AI model. Azure OpenAI deployment name. This is the unique name you assign to your deployment, making it identifiable within the Azure OpenAI service. Outputs. Azure OpenAI deployment configuration. This is the finalized configuration you created and deployed, specifying all the settings and parameters of your deployment. Deployment success status. This output indicates whether the deployment was successful or if any errors occurred during the deployment process. Steps. Navigate to Azure portal. The initial step is to access the Azure portal, the centralized management platform for your Azure services. Select Azure OpenAI resource within the Azure portal. Locate the Azure OpenAI service resource you previously created or are currently using. Select deployments within the Azure OpenAI service resource. Choose the deployments section, which manages the deployment of models to serve your applications. Select Create Deployment. Initiate the deployment process by clicking the Create Deployment option. Initiating the configuration process for your selected model. Provide deployment name. Assign a unique name to your deployment to identify it within the Azure OpenAI service and for reference within your application. Select model and deployment type. Choose the specific AI model you want to deploy and define a type of deployment, such as Text DaVinci 003 for text generation tasks. Configure deployment settings. Customize the deployment settings to tailor the model's behavior for your specific needs, such as setting resource limits, defining deployment regions, and configuring other parameters. Review and create deployment. Carefully review the configured settings before finalizing a deployment process, ensuring everything is configured correctly. Prerequisites. Azure subscription. You need an active Azure subscription to access the Azure OpenAI service and manage your deployments. Azure OpenAI resource. A dedicated Azure OpenAI resource must be created within your Azure subscription to host your AI models and deployments. Model to deploy. Before deploying, you must select a specific AI model from the available models offered by Azure OpenAI, each with its specialized capabilities. Fine-tune parameters. Training data. This refers to the data used to fine-tune the chosen AI model for your specific task, enhancing its performance in the desired area. Fine-tuning model type. This parameter specifies the type of fine-tuning method used to customize a AI model, such as supervised learning or reinforcement learning. Metrics. Accuracy. This metric measures how well the deployed AI model performs on its intended tasks, reflecting its ability to generate accurate and relevant outputs. Latency. This metric reflects the time taken for the AI model to process a request and generate a response, a crucial factor for real-time applications. Visualization plots. Training loss curve. This visualization graph shows the model's training loss over iterations, providing insights into its learning progress. Accuracy curve. This graph illustrates the model's accuracy performance over iterations, demonstrating how well it learns from the training data. Error analysis. Model predictions vs actuals. This analysis compares the model's predictions with the actual expected outputs, revealing any discrepancies and potential areas for improvement. Error distribution. This analysis visualizes the distribution of errors made by the model, providing insights into common mistakes and potential biases. Challenges and fixes. Challenge 1. Insufficient training data. Fixes to Challenge 1. Increase training data size. A larger training dataset can improve the model's generalization ability and reduce overfitting. Improve data quality. Ensuring the quality and relevance of training data is crucial for accurate and effective model performance. Challenge 2. Model overfitting. Fixes to Challenge 2. Use regularization techniques. Techniques like L1 and L2 regularization can prevent overfitting by penalizing complex models. Early stopping. Monitoring the model's performance during training and stopping at an optimal point can prevent overfitting to the training data. Challenge 3. Deployment failure. Fixes to Challenge 3. Verify deployment settings. Carefully review the deployment settings to ensure all configurations are accurate and consistent. Check resource availability. Ensure sufficient resources are available for the deployment to succeed, such as memory and processing power. Troubleshoot Azure OpenAI service. Investigate any potential issues with the Azure OpenAI service itself, such as connectivity problems or service outages. Contact Azure support if the issue persists. Reach out to Azure support for assistance in diagnosing and resolving the deployment failure. Inputs. An Azure subscription is a necessary prerequisite for creating and managing Azure resources, including Azure OpenAI resources. It provides a billing account, access to Azure services, and the ability to manage users and permissions within your Azure environment. An Azure OpenAI resource represents a deployment of an OpenAI model, such as GPT-3 or Codex, within your Azure environment. It allows you to access and utilize the power of these models for tasks like text generation, translation, and code completion. An Azure Active Directory. Azure AD application is a representation of an application within your Azure Active Directory tenant. It provides a mechanism for securing access to resources, managing user authentication, and authorizing applications to access specific resources. Outputs. An Azure OpenAI client application is a software application that interacts with an Azure OpenAI resource. This application utilizes an API key to authenticate with the Azure OpenAI service and execute various tasks, such as text generation, translation, and code completion. Steps. Navigate to the Azure portal, a web-based management interface for Azure resources. Select the Azure OpenAI resource that you want to interact with. This will bring you to the Resources Management page. Click on the Client Applications section within the Azure OpenAI Resources Management page. This will display the existing client applications and allow you to create new ones. Click on the Add Client Application button to initiate the process of creating a new client application for your Azure OpenAI resource. Select the Azure Active Directory application option from the available choices. This indicates that you want to create a client application that leverages Azure AD for authentication and authorization. Configure the application settings for your new client application. This includes defining the application name, redirect URI if required, permissions for accessing the Azure OpenAI resource, and other relevant settings. Review the configured application settings and proceed to create the application. This will finalize the creation of your client application, enabling it to interact with the Azure OpenAI resource. Prerequisites. An Azure subscription is a necessary prerequisite for creating and managing Azure resources, including Azure OpenAI resources. It provides a billing account, access to Azure services, and the ability to manage users and permissions within your Azure environment. An Azure OpenAI resource represents a deployment of an OpenAI model, such as GPT-3 or Codex, within your Azure environment. It allows you to access and utilize the power of these models for tasks like text generation, translation, and code completion. An Azure Active Directory Azure AD application is a representation of an application within your Azure Active Directory tenant. It provides a mechanism for securing access to resources, managing user authentication, and authorizing applications to access specific resources. Fine-tune parameters. The model type refers to the specific OpenAI model you intend to use for your client application. This could be GPT-3 for language tasks, Codex for code generation, or other available models based on your needs. The deployment name is a unique identifier for the specific instance of the chosen OpenAI model. Within your Azure environment, it allows you to distinguish and manage different model deployments for various purposes. The API key is a secret credential that enables your client application to authenticate with a Azure OpenAI service. It provides secure access to the deployed OpenAI model and its capabilities, allowing your application to interact with the model and utilize its functionality. Metrics. Request latency measures the time taken for an API call from your client application to be processed and return a response from the Azure OpenAI service. It reflects the efficiency and responsiveness of the model and can impact the overall performance of your application. API calls represent the number of requests your client application sends to the Azure OpenAI service to interact with the deployed model. This metric provides insights into the usage patterns and frequency of interaction with the model, offering valuable data for optimization and resource allocation. Visualization plots. API call frequency is a visualization that represents the distribution and pattern of API calls made by your client application over a specific time period. It provides a visual representation of how frequently the model is being used, allowing you to identify trends, peak usage periods, and areas for potential optimization. Model performance metrics are visualizations that illustrate various aspects of the model's performance during its interaction with your client application. This could include metrics like accuracy, fluency, coherence, or other relevant indicators depending on the model's specific capabilities and the tasks it is being used for. These visualizations provide valuable insights into the model's overall effectiveness and can assist in identifying areas for improvement. Error analysis. API key errors occur when your client application fails to authenticate with the Azure OpenAI service due to issues with the provided API key. This could include invalid keys, expired keys, or insufficient permissions associated with the key. These errors prevent your application from accessing the model and its capabilities. Model deployment errors arise when there are issues with the deployment of the chosen OpenAI model within your Azure environment. This could include incorrect configuration settings, network connectivity problems, or issues with the underlying model infrastructure. These errors prevent your application from successfully interacting with the deployed model. Challenges and fixes. API key access issues can occur due to various reasons, including invalid keys, expired keys, or insufficient permissions associated with the key. This prevents your client application from authenticating with the Azure OpenAI service and accessing the model. One solution is to regenerate the API key, obtaining a new and valid key with appropriate permissions. Incorrect deployment names can occur if the name provided in your client application's configuration does not match the actual deployment name of the chosen OpenAI model within your Azure environment. This leads to communication issues between your application and the deployed model. The solution involves verifying the deployment name in your application settings and ensuring it aligns with the actual deployment within Azure. Insufficient permissions occur when your client application lacks the necessary permissions to access the Azure OpenAI resource and interact with the deployed model. This restricts your application's ability to utilize the model's capabilities. Granting required permissions to your client application within Azure AD resolves this issue. By providing the necessary authorization, your application can access and interact with the model without any permission-related restrictions. Inputs: Azure subscription. This represents the specific Azure subscription you are using to deploy a OpenAI model. It is a unique identifier associated with your Azure account, allowing access to Azure resources and billing information. Azure Resource Group. This refers to the grouping of Azure resources related to your OpenAI model. Deployment: it acts as a container for managing and organizing resources such as virtual machines, storage accounts, and network configurations. Azure OpenAI model. This indicates the specific OpenAI model you intend to deploy to Azure. This could be a pre-trained model from OpenAI's library or a custom model trained on your own data. Deployment configuration. This involves the settings and parameters for configuring the deployment environment for the Azure OpenAI model. It includes details like the deployment region, model resource size, and access control settings. Outputs: deployed Azure OpenAI model. This refers to the final state of the OpenAI model after it has been successfully deployed to Azure. It represents the operational model accessible through the Azure OpenAI service. Model endpoint: this is the unique URL or address of the deployed Azure OpenAI model, providing a way to interact with the model and send requests for predictions or other services. Steps: create Azure Resource Group. This step involves setting up the necessary Azure Resource Group to host the OpenAI model deployment. This involves defining the region and name of the resource group and ensuring that it has the required permissions for deploying Azure resources. Deploy Azure OpenAI resource. This step focuses on deploying the Azure OpenAI resource itself, creating the necessary infrastructure to host the OpenAI model. This includes provisioning the required compute resources, storage, and network configurations for the model. Configure model endpoint. This step involves setting up the endpoint for the deployed Azure OpenAI model. This includes defining the access permissions, setting up security measures, and configuring the endpoint to handle requests from clients. Deploy model to endpoint. This step focuses on deploying the actual OpenAI model to the configured endpoint. This involves uploading the model files, configuring the model settings, and making it ready to receive requests and provide predictions. Prerequisites: Azure subscription as described earlier. This refers to the Azure subscription required for accessing Azure services and deploying resources. Azure Resource Group. This refers to the Azure Resource Group that will house the OpenAI model deployment, requiring it to be created beforehand. Azure OpenAI resource. This refers to the Azure OpenAI resource instance, which needs to be created in Azure before deploying the model. It provides the necessary infrastructure to host and manage the OpenAI model. Fine-tune parameters. Learning rate. This represents the rate at which the model adjusts its weights during the fine-tuning process. A higher learning rate results in larger adjustments, while a lower rate leads to more subtle updates. Epochs. This refers to the number of times the training data is iterated through during the fine-tuning process. More epochs can lead to better model performance but also increase training time. Batch size. This parameter defines the number of training samples used in each iteration of the fine-tuning process. A larger batch size can accelerate training but may require more memory. Metrics. Accuracy. This metric assesses the model's ability to correctly classify data points. It measures the percentage of predictions that align with the actual labels. Precision. This metric focuses on the proportion of correctly classified positive instances among all instances predicted as positive. It highlights the model's ability to avoid false positives. Recall. This metric measures the proportion of correctly classified positive instances among all actual positive instances. It emphasizes the model's ability to identify all true positives. Visualization plots. Loss curve. This plot visualizes the model's training loss over time, providing insights into how well the model is learning and improving during training. Confusion matrix. This plot displays the distribution of correct and incorrect predictions, highlighting the model's performance across different classes and its potential biases. Error analysis. Misclassified samples. This refers to the data points that the model incorrectly predicted during evaluation. Analyzing these samples can help identify areas where the model struggles and inform further improvements. Error types. This refers to the different categories or types of errors made by the model during prediction. Understanding these error types can help pinpoint specific areas for improvement, such as addressing biases or improving model performance on certain data patterns. Challenges and fixes. Challenge 1. Model deployment failure. This refers to scenarios where the deployment process for the Azure OpenAI model encounters issues or errors, preventing the model from being successfully deployed and operational. Fixes to Challenge 1. Check resource group. This involves verifying that the Azure resource group associated with the deployment is correctly configured and has the necessary permissions and resources to host the OpenAI model. Verify model access. This involves ensuring that the Azure OpenAI resource has the appropriate access permissions to the deployed model files and that there are no authentication or authorization issues preventing the resource from interacting with the model. Challenge 2. Model performance issues. This refers to scenarios where the deployed Azure OpenAI model does not perform as expected, exhibiting issues such as low accuracy, high latency, or other performance problems. Fixes to Challenge 2. Fine-tune parameters. This involves adjusting the hyperparameters of the model, such as the learning rate, epochs, and batch size, to improve its performance and achieve better results on the target dataset. Data preprocessing. This involves examining the data used for training and deployment, ensuring that it is properly formatted, cleaned, and preprocessed to minimize noise and improve the model's performance. Model selection. This involves considering alternative models or architectures that might be better suited for the specific task and dataset, potentially leading to improved performance and accuracy. Inputs. Azure subscription. This refers to the Azure account that you have, which is needed to access and use the Azure OpenAI service. This is the account where you manage your resources and subscriptions. Azure OpenAI service. The specific Azure service that provides access to OpenAI models. This service is where you manage the models you will use for tasks like text generation, translation, and more. Outputs. Installed Azure OpenAI SDK. The necessary software package that allows your Python program to interact with the Azure OpenAI service. This SDK provides functions for making requests to the Azure OpenAI service and handling the responses. Steps. Install Python. This is the fundamental programming language that is required to use the Azure OpenAI SDK. Python is a popular language for data science and machine learning, which are often involved when working with language models. Install Azure SDK for Python. This installs the Azure SDK, a collection of libraries that provide access to Azure services, including the OpenAI service. It enables you to connect your Python application to the Azure infrastructure. Install Azure OpenAI Client Library. This is the specific package that allows your Python application to interact directly with the Azure OpenAI service. It provides functions for calling specific models, sending prompts, and retrieving responses. Prerequisites: Python installed. This confirms that you have Python installed on your system before proceeding with the installation steps. It ensures that the required environment is in place. Fine-tune parameters. Model name: the specific language model you choose to work with from the Azure OpenAI service. This could be a model like GPT-3 or any other available model that suits your needs. Training data: the data you provide to train or fine-tune the chosen model. This data should be specific to your task and should be relevant to the model's capabilities. Metrics. Model accuracy: this refers to how well the model performs on a given task. It is usually measured by comparing the model's outputs to the expected or desired outputs. Model performance: this refers to the overall effectiveness and efficiency of the model. It can be assessed by considering factors like speed, accuracy, and resource consumption. Visualization plots. Confusion matrix: this is a visualization tool that shows the performance of a classification model by depicting the correct and incorrect predictions made by the model. It helps identify areas of strength and weakness in the model's predictions. ROC curve: this is another visual tool used to assess the performance of a classification model. It shows the trade-off between the model's true positive rate sensitivity and its false positive rate. Specificity. Error analysis. Incorrect predictions: these are instances where the model's predictions do not match the expected or correct outputs. Analyzing these errors helps identify areas where the model may be struggling or where the training data might be inadequate. Model bias: this refers to systematic errors or deviations in the model's predictions that are influenced by biases present in the training data or the model's architecture. It is important to identify and mitigate bias to ensure the model makes fair and accurate predictions. Challenges and fixes. Azure OpenAI service not found: this error might occur if the specified Azure OpenAI service name is incorrect or if the service is not properly provisioned. Verify service name: double-check the name of your Azure OpenAI service and ensure that it matches the one you are trying to access. Authentication error: this error might occur if the provided API key is invalid or if the authorization process is not successful. Check API key: ensure that you have a valid API key associated with your Azure OpenAI service. You can obtain this key from the Azure portal. API rate limit exceeded: this error means you have exceeded the maximum number of requests allowed for your Azure OpenAI service within a specified time period. Reduce API calls: you can optimize your code to make fewer API calls or consider using a larger quota for your service to accommodate your usage. Inputs. This input is the endpoint of the Azure OpenAI service, the URL that points to the location of the service in the Azure cloud. For instance, you might have an endpoint like https yourresourcename.openai.azure.com. This input is the API key that grants access to the Azure OpenAI service. It's akin to a password that allows your application to use the service. You'd typically obtain this key from the Azure portal when setting up your Azure OpenAI resource. Outputs. This output represents the successful integration of the Azure OpenAI library into your project. Once imported, you can utilize its functions and classes to interact with the Azure OpenAI service. Steps. This step involves installing the Azure OpenAI library into your project using a package manager like pip. It makes the library's components accessible for use within your code. This step creates an Azure OpenAI client object, which is a bridge between your application and the Azure OpenAI service. This client allows you to communicate with the service and make requests to it. Prerequisites. You need an Azure subscription to access the Azure OpenAI service. This subscription grants you access to the Azure platform and its resources, including the OpenAI service. You need an Azure OpenAI resource, which is the specific instance of the OpenAI service in your Azure environment. You can create this resource through the Azure portal, where you'll configure its settings, such as the deployment region and pricing tier. Fine-tune parameters. This parameter specifies the model you want to fine-tune. Azure OpenAI offers various models for different tasks, such as text generation or code completion. Each model has its strengths and weaknesses, so choosing the right one is crucial for successful fine-tuning. This parameter is the data you provide to the model for training. This data should be relevant to the task you want the model to perform and must be in a format a model can understand. Good training data is essential for achieving accurate and reliable results from fine-tuning. Metrics. This metric represents the loss function used during model training. It measures the difference between the model's predictions and the actual values in the training data. Lower loss generally indicates better model performance. This metric represents the accuracy score of the model. It measures the percentage of correct predictions the model makes on a given dataset. A higher accuracy score usually implies a more reliable model. Visualization plots. This visualization plot shows how the loss function changes during the training process. It allows you to observe the model's progress and identify potential issues, such as overfitting, where the model becomes too specialized in the training data and performs poorly on new data. This visualization plot is a visual representation of the model's performance. It shows how the model classifies data points and helps identify areas where the model is making errors. This can be useful for identifying biases in the model and improving its overall accuracy. Error analysis. This part of the analysis focuses on identifying specific data samples where the model made incorrect predictions. Examining these misclassified samples can provide insights into the model's weaknesses and areas for improvement. This analysis investigates potential biases in the model. It aims to identify if the model exhibits systematic errors or inaccuracies based on certain characteristics of the input data. This is important for ensuring fairness and preventing unintended consequences in the models. Predictions, challenges and fixes. This challenge occurs when the API key provided to access the Azure OpenAI service is incorrect or invalid. This can prevent the application from successfully interacting with the service. This fix involves verifying the API key's validity. Ensure that the key is correct and has not expired. You can also check if the key has the necessary permissions for the requested actions. This challenge arises when the training data provided to fine-tune the model is insufficient. Insufficient data can lead to poor performance and inaccurate predictions. This fix involves increasing the size of the training data. Providing the model with more relevant and diverse data can help it learn better and improve its accuracy. Inputs. Unique identifier for the Azure subscription that hosts the Azure OpenAI resource. For example, Name of the Azure resource group that contains the Azure OpenAI deployment. For example, My Resource Group. Name of the Azure OpenAI deployment that hosts the model you want to use. For example, My Deployment. Secret key associated with the Azure OpenAI deployment. Used to authenticate and authorize requests to the Azure OpenAI service. For example, your API key. Outputs. Object representing the connection to the Azure OpenAI service, enabling you to interact with the deployed model. This object is used to send requests to the model and receive responses. Steps. 1. Import the necessary Azure OpenAI library. 2. Create an Azure OpenAI client object using the imported library. 3. Specify the Azure subscription ID, Azure resource group name, Azure OpenAI deployment name, and Azure OpenAI API key as parameters. Prerequisites. An active Azure subscription with the necessary permissions to access and use the Azure OpenAI resource. This includes having the required role assignments and access control policies. An Azure OpenAI deployment that has been created within your Azure subscription. Hosting the specific model you intend to use. An Azure OpenAI API key that has been generated and associated with the Azure OpenAI deployment, allowing you to authenticate and access the model through the client object. Fine-tune parameters. Options and settings related to the process of fine-tuning a pre-trained model on your specific dataset. This includes parameters such as learning rate, epochs, batch size, and other hyperparameters. Steps involved in preparing your training data for the fine-tuning process, including data cleaning, formatting, and splitting into training, validation, and test sets. Process of training the model on your prepared data using the specified parameters. This involves iteratively adjusting the model's weights to minimize the loss function. Metrics. Measures used to evaluate the performance of the fine-tuned model on your specific task. This could include metrics such as accuracy, precision, recall, F1 score, and others relevant to your domain. Measures of the model's loss function during the training process. This provides insight into how well the model is learning and fitting the training data. Time taken to train the model on your data. This is an important consideration, especially when dealing with large datasets or complex models. Visualization plots. Plots that visually represent the performance of the fine-tuned model. This could include plots showing accuracy, loss, or other relevant metrics over time. Plots that visualize the distribution of your training data, helping you understand potential biases or imbalances. Plots that show the training loss over time, providing insight into the learning progress of the model. Error analysis. Techniques used to identify errors and misclassifications made by the fine-tuned model. This could include analyzing the model's predictions on test data and comparing them to the ground truth. Methods used to analyze and understand the causes of errors made by the model. This could involve examining the input data, the model's internal representations, and the model's decision-making process. Strategies employed to correct errors made by the model, which could involve data augmentation, model retraining, or adjusting the model's architecture. Challenges and fixes. Challenge 1. API key not accessible or invalid. Fix. Check the API key validity and ensure it is correctly passed as a parameter. Challenge 2. Incorrect Azure resource group name. Fix. Verify the Azure resource group name and ensure it is correct. Inputs. Azure subscription. This refers to your active Azure account, which gives you access to various Azure services, including Azure OpenAI. Azure OpenAI resource. This is a specific instance of the Azure OpenAI service within your Azure Subscription. You deploy your chosen AI model, e.g., GPT-3 Codex to this resource. Outputs. Configured connection. This represents the successful linking of your Azure application or environment to your Azure OpenAI resource, enabling communication and interaction. Ability to use Azure OpenAI models. Once connected, you gain the capacity to send requests to your deployed AI models and receive responses, allowing you to utilize their capabilities for various tasks. Steps. Create an Azure OpenAI resource. You need to provision a dedicated Azure OpenAI resource within your Azure subscription, which acts as the container for your AI model. Configure the Azure OpenAI resource. After creation, you must configure the resource with the specific AI model you want to use, e.g., Text DaVinci 003 for general text generation. Connect your Azure application, e.g., a web app. A Python script needs to be connected to the Azure OpenAI resource using its unique endpoint and API key. Use the Azure OpenAI SDK. The Azure OpenAI SDK provides libraries and tools for easily interacting with the deployed AI models within your Azure application. Prerequisites. Active Azure subscription. With access to Azure OpenAI service, you need an active Azure subscription that has access to the Azure OpenAI service, which may require additional configuration or approval. Basic understanding of Azure resources and Azure OpenAI service. Familiarity with fundamental concepts related to Azure resources like resource groups, subscriptions, and deployment in the Azure OpenAI service is helpful. Fine-tune parameters. Model-specific parameters. Fine-tuning parameters vary depending on the chosen AI model and your specific task. For instance, GPT-3 might have parameters related to temperature, top P, and frequency penalty, which can influence the style and coherence of the generated text. Common fine-tuning parameters. Some parameters are common across many models, such as learning rate. This parameter controls the step size during the fine-tuning process, influencing how quickly the model adapts to your specific data. Epochs. This refers to the number of passes through the training data, determining how many times the model learns from the data. Batch size. This parameter specifies the number of data points processed at each step of training, influencing the computational efficiency and memory usage. Metrics. Model performance metrics to assess the effectiveness of the fine-tuned AI model. Various metrics are used. Accuracy. A measure of how well the model correctly predicts the output for a given input. Precision indicates the proportion of correct predictions among all positive predictions. Recall represents the proportion of actual positive cases that the model correctly identified. Performance efficiency metrics. Latency. The time taken for the model to process a request and generate a response. Throughput. The number of requests the model can handle per unit of time. Visualization plots. Model performance metrics over time. By plotting model performance metrics, e.g., accuracy, recall across different training stages or iterations, you can visualize the model's learning progress and identify potential areas of improvement. Model internal activations. Visualizing the internal activations of the AI model. The internal states or values of neurons can offer insights into how the model is processing information and making decisions. This can help understand the model's behavior and identify potential biases or limitations. Error analysis. Error identification and analysis. A crucial step is to identify the errors made by the AI model during its predictions. Analyze these errors to understand their patterns, causes, and potential impact. Error mitigation strategies. Based on the error analysis, Determine strategies to address these errors. This could involve data augmentation, increasing the diversity and quantity of training data, model architecture adjustments, modifying the internal structure of the model, parameter tuning, experimenting with different values for the fine-tuning parameters. Challenges and fixes. Challenge 1. API key and endpoint validation. Make sure you are using the correct API key for your specific Azure OpenAI resource and that the resource endpoint is correctly configured in your Azure application. Challenge 2. Model deployment and configuration. Verify that the AI model you are using is correctly deployed to your Azure OpenAI resource and configured according to your specific task. For example, ensure the model is fine-tuned for the desired language, domain, or task. Inputs. Azure subscription represents the Azure subscription under which the OpenAI endpoint will be provisioned. This subscription must have the necessary permissions and resources to create an Azure OpenAI resource. For example, you may need a specific Azure subscription that allows the creation of OpenAI resources and has the required quotas and billing information. OpenAI Resource Group refers to the Azure Resource Group where the Azure OpenAI resource and its associated components will be deployed. A resource group is a logical container for related resources, helping manage and organize your Azure resources. For instance, you might create a dedicated resource group for all your Azure OpenAI related assets, such as the endpoint, deployments, and associated storage. Outputs. Azure OpenAI endpoint represents the fully provisioned and configured Azure OpenAI endpoint, ready to accept and process requests. This endpoint acts as the gateway to the OpenAI services, allowing you to make calls to generate text, translate languages, summarize content, and perform other AI tasks. For example, you might have an endpoint named My OpenAI endpoint that provides access to the GPT 3.5 model. Steps. Create Azure OpenAI resource involves the creation of the core Azure OpenAI resource within a designated resource group. This step usually includes specifying the desired deployment region, pricing tier, and other configuration parameters. For example, you might create an Azure OpenAI resource with the standard pricing tier and deploy it in the West Europe region. Configure Azure OpenAI endpoint encompasses the process of setting up the specific Azure OpenAI endpoint, including defining its name, access policies, and connecting it to the appropriate models. This step might involve choosing which OpenAI models like GPT-3 or Codex will be available through the endpoint and defining rules for accessing and using these models. For example, you might configure an endpoint to allow only certain users or applications to access specific models, enforcing security and access controls. Prerequisites. Azure subscription represents the Azure subscription required to deploy and manage Azure OpenAI resources. You need an active Azure subscription to access the necessary tools, services, and billing mechanisms for utilizing OpenAI capabilities. For instance, your Azure subscription might be linked to a company account, providing access to various resources and allowing you to manage your Azure OpenAI deployments. Azure OpenAI Service Plan refers to the chosen service plan for your Azure OpenAI resource. This plan determines the pricing, compute resources, and other capabilities associated with your OpenAI deployment. For example, you might select a service plan that offers a balance between cost and performance, depending on your specific usage requirements. Fine-tune parameters. Deployment region specifies the geographical location where the Azure OpenAI resource will be deployed. The choice of region can impact factors such as latency, data sovereignty, and compliance. For instance, you might choose to deploy your Azure OpenAI resource in a region closer to your users to minimize latency, or in a specific region to comply with data residency requirements. Endpoint name defines the unique identifier for your Azure OpenAI endpoint. This name will be used to refer to and access the endpoint for all subsequent interactions. For example, you might name your endpoint My OpenAI endpoint, making it easy to identify and access within your Azure environment. Metrics. Endpoint availability represents the availability of the Azure OpenAI endpoint, indicating whether it is up and running and responsive to requests. This metric is crucial for gauging the health and reliability of your OpenAI deployment. For instance, monitoring endpoint availability allows you to detect any downtime or performance issues and take corrective actions to ensure smooth operation. Request latency measures the time it takes for the Azure OpenAI endpoint to process and respond to requests. Latency is a key performance indicator for evaluating the responsiveness of your OpenAI deployment. For example, low latency is desirable for real-time applications and interactive scenarios, while higher latency might be acceptable for batch processing or offline tasks. Visualization plots. Endpoint usage over time visualizes the usage patterns of the Azure OpenAI endpoint over a specific period. This plot provides insights into the frequency and volume of requests made to the endpoint, helping you understand the overall demand and resource consumption. For example, you might use this plot to identify peak usage periods and optimize your deployment resources accordingly. Request latency distribution displays the distribution of request latencies experienced by a Azure OpenAI endpoint. This plot helps analyze the performance characteristics of the endpoint, identifying any potential bottlenecks or areas for improvement. For example, you might observe a skewed distribution of latencies, indicating a need to optimize the underlying infrastructure or refine the configuration. Error analysis. Authentication errors represents errors related to authentication issues when accessing the Azure OpenAI endpoint. These errors occur when there are problems verifying user credentials or accessing authorized resources. For example, you might encounter authentication errors if you use incorrect API keys, have insufficient permissions, or if there are network connectivity issues. Rate limiting issues occur when the Azure OpenAI endpoint encounters rate limits, restricting the number of requests you can send within a given time frame. These limits are implemented to prevent abuse and ensure fair usage of the OpenAI services. For instance, you might experience rate limiting issues if you exceed the defined request limits or if there are sudden surges in demand for the endpoint. Challenges and fixes. Challenge 1. Resource creation failures. Fixes to Challenge 1. Check subscription quota involves verifying if the Azure subscription has enough quota to support the creation of the requested Azure OpenAI resource. Quota limitations can prevent the creation of new resources, such as endpoints or models. For example, you might encounter a quota error if your subscription has reached its maximum allowed number of OpenAI resources or has exceeded its allocated storage capacity. Verify resource group permissions checks if the specified Azure resource group has the necessary permissions for creating the Azure OpenAI resource. Permissions control access to resources and ensure that users have the authority to perform specific actions. For example, you might need to ensure that the user or service principal associated with your Azure subscription has the appropriate role-based access control (RBAC) permissions to create OpenAI resources within a target resource group. Challenge 2. Endpoint configuration issues. Fixes to challenge 2. Check deployment region availability verifies if the chosen deployment region for the Azure OpenAI resource is currently available. Not all regions may support OpenAI deployments, and availability can vary based on Azure's regional infrastructure and service offerings. For example, you might encounter an error if you attempt to deploy an OpenAI resource in a region that is not currently supported, or if the region is experiencing maintenance or outages. Verify endpoint name uniqueness ensures that the chosen endpoint name is unique within the Azure resource group. Endpoint names must be unique to avoid conflicts and ensure proper identification. For example, if you attempt to create an endpoint with a name that already exists in the resource group, you might encounter an error or be prompted to choose a different name. Inputs. This input represents the name of the Azure OpenAI resource you've created in Azure portal. It's essential for identifying your specific instance of OpenAI service within Azure. For example, you might name your resource My OpenAI Source. This input represents the unique identifier assigned to your Azure OpenAI resource, allowing you to authenticate and access its capabilities. It's crucial for security and ensuring only authorized users can interact with your OpenAI resource. You can find this API key within the Azure portal, under the Keys and Endpoints section of your OpenAI resource. Outputs. This output signals the successful completion of the process of setting the Azure OpenAI API key. This means the API key is now ready to be utilized for accessing and interacting with the Azure OpenAI service. Steps. Navigate to the Azure portal, the centralized management interface for Azure services. Access your Azure OpenAI resource from the portal. This can be done by searching for your resource's name using the search bar in the Azure portal. Once you've accessed your OpenAI resource, locate the Keys and Endpoints section, typically within the Resources Configuration menu. Within the Keys and Endpoints section, you'll find the primary key field. This is the essential key required for authenticating your applications and accessing the Azure OpenAI service. Copy this key carefully. Set an environment variable within your development environment using the copied API key. This variable will make the key easily accessible to your code, simplifying the authentication process. For example, you might set the environment variable name as Azure OpenAI API key. Prerequisites. An active Azure subscription is necessary to create and manage Azure OpenAI resources, which are required to use the OpenAI service within Azure. You can sign up for a free Azure trial account to get started. An Azure OpenAI resource represents your dedicated instance of the OpenAI service within Azure. It's essential for providing you with a secure and managed environment for using OpenAI models and capabilities. You need to create this resource in the Azure portal before proceeding with the API key setup. Fine-tune parameters. This field represents any additional parameters you might want to use for fine-tuning the Azure OpenAI models. Fine-tuning allows you to adapt the models to your specific needs and datasets, making them more accurate and relevant for your applications. Metrics. This field represents any metrics or measurements you might want to track during the process of using Azure OpenAI services. This could include performance indicators, error rates, or resource consumption to help you monitor the efficiency and effectiveness of your AI operations. Visualization plots. This field represents any visualizations or plots you might want to generate to visually understand the results or insights obtained from using Azure OpenAI services. Visualizations can help you identify patterns, trends, and key areas of interest within your data. Error analysis. This scenario occurs when the provided API key is incorrect or invalid. This could be due to typos, incorrect copying, or expired keys. The solution involves verifying the API key carefully to ensure it matches the actual key for your Azure OpenAI resource. Verify the API key by double-checking its value and ensuring that it's correctly copied and pasted into your code or environment variable. Additionally, confirm that the key is still active and hasn't expired. This scenario occurs when the specified Azure OpenAI resource name doesn't match any existing resources in your Azure subscription. This could be due to typos or incorrect naming. Check the resource name for any typos or errors. Ensure that the name exactly matches the name of the resource you created in the Azure portal. You might need to refer back to the resource's details in the Azure portal to confirm the accurate name. Challenges and fixes. This challenge arises when your application or code lacks the necessary permissions to access the Azure OpenAI resource using the provided API key. This might be due to incorrect role assignments or limited access privileges within your Azure account. Check permissions by reviewing the role assignments associated with your Azure account and ensuring that your user or service principal has sufficient privileges to access the Azure OpenAI resource. You might need to consult Azure documentation or contact Azure support for assistance with role assignment management. This challenge occurs when the API key provided is no longer valid. This can happen due to security reasons, expiration policies, or potential key compromise. Regenerate API key by accessing the Keys and Endpoints section of your Azure OpenAI resource in the Azure portal and selecting the Regenerate Key option. This will generate a new API key, replacing the old one. Be sure to update your code or environment variable with the newly generated API key. Inputs. The Azure OpenAI resource to be deployed. This is a resource that is created in Azure and provides access to the Azure OpenAI service, which includes different models for natural language processing tasks. This is the name given to the deployment. It is a user-defined identifier that distinguishes the deployment from other deployments within the Azure OpenAI resource. Outputs. The name assigned to the deployment. This will be the same as the deployment name provided as input. The endpoint URL for the deployed model. This is the URL that clients use to access and interact with the deployed model. Steps. Navigate to the Azure portal, which is the web-based management interface for Azure resources. Locate and select the Azure OpenAI resource that you want to deploy the model to. Within the Azure OpenAI resource, select the Deployment section. This section is where you manage and deploy different models. Click on the Create Deployment button. This action initiates the process of deploying a new model. Provide a unique name for the deployment. This name will be used to identify the deployment and is important for reference and management purposes. Select the specific OpenAI model you wish to deploy. Azure OpenAI offers various models for different natural language processing tasks, such as text generation, translation, and summarization. Choose the appropriate pricing tier for your deployment. Azure OpenAI provides different pricing tiers based on the model size, performance, and usage requirements. Click the Create button to finalize the deployment process. This starts the process of provisioning and configuring the selected model on the Azure infrastructure. Prerequisites. An active Azure subscription is necessary to access and manage Azure resources, including the Azure OpenAI service. An Azure OpenAI resource must be created within your Azure subscription. This resource provides the infrastructure and access to the Azure OpenAI service. Fine-tune parameters. The OpenAI model to be fine-tuned. This is the base model that will be adapted to specific use cases and domains. The data used to fine-tune the model. This data should be specific to the use case and domain and should be carefully selected and prepared for the fine-tuning process. Metrics. The time it takes for the deployed model to respond to a request. This metric is crucial for understanding the performance of the model and identifying potential bottlenecks. The cost incurred for running the deployment. This metric is essential for cost management and optimization. Visualization plots. Visual representations of the model's performance metrics, such as accuracy, precision, and recall. These plots provide insights into the model's effectiveness. Visual representations of the deployment cost over time. These plots help monitor and analyze the cost of running the deployment. Error analysis. Logs that capture any errors encountered during the deployment process. These logs are invaluable for debugging and troubleshooting issues. Continuous monitoring of the deployment's performance metrics. This helps identify any performance deviations or anomalies that require investigation. Challenges and fixes. Deployment failures can occur due to various reasons, such as insufficient resources, configuration errors, or network issues. Check the available resources and ensure they are sufficient for the deployment. Verify that the deployment configuration is correct and aligns with the chosen model and pricing tier. Deployment performance issues, such as slow response times or high latency, can be caused by factors like resource contention or inefficient configuration. Analyze the resource utilization patterns to identify any bottlenecks or areas where resources are not being used effectively. Optimize the deployment configuration to improve performance and minimize resource consumption. Cost optimization is crucial for managing deployment costs effectively. Select the appropriate pricing tier that balances performance and cost. Implement cost management strategies, such as monitoring usage, setting budgets, and optimizing resource allocation. Inputs. Azure OpenAI Service. This refers to the Azure OpenAI Service, a cloud-based service that provides access to powerful language models like GPT-3. It allows developers to integrate AI capabilities into their applications. Training data. This represents the data used to train the Azure OpenAI model. It should be relevant to the task the model is intended for. For example, if you are building a chatbot, the training data would consist of conversational text. Outputs. Fine-tuned model. This represents the model that has been trained on the specific training data, resulting in a model that's optimized for the desired task. Model performance metrics. These are metrics that assess the performance of the fine-tuned model. These metrics can include measures like accuracy, precision, and recall, providing insights into the model's effectiveness. Steps. 1. Prepare data. 2. Select model. 3. Fine-tune model. 4. Evaluate model. Prerequisites. Azure subscription. A valid Azure subscription is necessary to access the Azure OpenAI service and its resources. Azure OpenAI resource. You need an Azure OpenAI resource, which is a dedicated resource within your Azure subscription for utilizing the Azure OpenAI service. Fine-tune parameters. Learning rate. This parameter determines how much the model adjusts its weights during the training process. A higher learning rate means faster adjustments but can lead to instability, while a lower learning rate can result in slower training but potentially better accuracy. Epochs. This parameter defines how many times the model goes through the entire training dataset during the training process. More epochs allow the model to learn more from the data, but excessive epochs can lead to overfitting. Metrics. Accuracy. Accuracy measures the proportion of correct predictions made by the model. It's a common metric for evaluating the overall performance of a model. Precision measures the proportion of true positive predictions among all positive predictions made by the model. It's useful for assessing the model's ability to correctly identify positive cases. Recall measures the proportion of true positive predictions among all actual positive cases. It's important for evaluating the model's ability to capture all positive cases. Visualization plots. Loss curve. This plot visualizes the model's loss function over training epochs. It provides insights into how well the model is learning and can identify potential issues like overfitting or underfitting. Confusion matrix. This visualization helps to understand the model's performance across different classes. It shows how many instances are correctly classified, as well as how many are misclassified, providing valuable insights into the model's strengths and weaknesses. Error analysis. Misclassified examples. These are examples from the dataset that the model failed to classify correctly. Examining these examples can help identify areas where the model struggles and understand why it makes mistakes. Error types. These are specific types of errors that the model makes. For instance, a model might misclassify a cat as a dog or vice versa. Analyzing error types can help in understanding the model's limitations and guide further improvements. Challenges and fixes. Challenge 1. Data imbalance. Fixes to challenge 1. Oversampling. This technique involves increasing the number of samples from the minority class in the dataset. This helps to balance the class distribution and prevent the model from being biased towards the majority class. Undersampling. This technique involves reducing the number of samples from the majority class in the dataset. It aims to balance the class distribution and avoid the model focusing too much on the majority class. Challenge 2. Model overfitting. Fixes to challenge 2. Regularization. This technique adds a penalty to the model's loss function for complex models. It encourages the model to be simpler and less likely to overfit to the training data. Early stopping. This technique monitors the model's performance on a validation set during training and stops the training process when the performance on the validation set starts to decrease. This prevents the model from overfitting to the training data and maintains its generalizability. This YAML represents the description of inputs, outputs, steps, prerequisites, fine-tuning parameters, metrics, visualizations, error analysis and challenges and fixes involved in using Azure OpenAI. Inputs. The inputs are the data that is used to train the Azure OpenAI model. This can include text, code, or other data that can be used to teach the model how to perform a specific task. For example, if you are training a model to generate creative text, you might use a data set of novels, poems, or other creative writing. The inputs should be relevant to the task that the model is being trained to perform. They should also be of high quality and free from errors. The inputs should also be representative of the type of data that the model will be used within the future. The outputs. The outputs are the results that are generated by the Azure OpenAI model. This can include text, code, or other data that is generated by the model. For example, if you are training a model to generate creative text, the output might be a poem or a short story. The outputs should be of high quality and relevant to the task that the model was trained to perform. They should also be consistent with the inputs that were used to train the model. Steps. The steps involved in training the Azure OpenAI model. This includes preparing the data, training the model, and evaluating the model's performance. This might involve pre-processing the data, splitting the data into training and test sets, and selecting a suitable model architecture. The steps should be carefully documented and reproducible. They should also be tailored to the specific task that the model is being trained to perform. Prerequisites. Prerequisites are the requirements that need to be met before training the Azure OpenAI model. This can include having access to the necessary hardware and software, as well as having the required skills and knowledge. The prerequisites should be clearly identified and met before beginning the training process. Fine-tune parameters. The fine-tuning parameters are the settings that can be adjusted to control the training process of the Azure OpenAI model. This can include the learning rate, the batch size, and the number of epochs. These parameters can be adjusted to optimize the performance of the model. The fine-tuning parameters should be carefully selected based on the specific task and the data that is being used to train the model. Metrics. The metrics are used to evaluate the performance of the Azure OpenAI model. This can include metrics such as accuracy, precision, recall, and F1 score. These metrics can be used to compare different models and to determine which model is performing the best. The metrics should be chosen based on the specific task that the model is being trained to perform. They should also be relevant to the data that is being used to evaluate the model. Visualization plots. Visualization plots are used to visualize the performance of the Azure OpenAI model. This can include plots showing the loss function, the accuracy, or other relevant metrics. This helps visualize how well the model is performing during training and can help identify any potential problems. The visualization plots should be clear and easy to understand. They should also be relevant to the task that the model is being trained to perform. Error analysis. Error analysis is the process of identifying and analyzing the errors that are made by the Azure OpenAI model. This helps understand why the model is making errors and how to improve its performance. This can involve analyzing the predictions made by the model and identifying the patterns in the errors. The error analysis should be conducted in a systematic and rigorous manner. The results of the error analysis should be used to improve the model's performance. Challenges and fixes. The challenges encountered during the process of using Azure OpenAI. This can include issues with data quality, model performance, or other technical challenges. These challenges should be documented and solutions should be identified to address them. These are the fixes that were implemented to address the challenges encountered during the process of using Azure OpenAI. They should be documented clearly and accurately, and the results of these fixes should be evaluated. This specification details the components of an Azure OpenAI model deployment, outlining the inputs, outputs, steps, prerequisites, fine-tuning parameters, metrics, visualizations, error analysis, and potential challenges and solutions. Inputs. The unique URL of the Azure OpenAI service instance that will be used to interact with the model. A secret key providing access to the Azure OpenAI service instance. The specific name of the Azure OpenAI model to be used, such as text DaVinci 003. The text input to be provided to the model, upon which it will perform its task. For example, a prompt for text generation, classification, or question answering. Outputs. The response generated by the Azure OpenAI model based on the provided prompt. This could be a generated text, a classification label, or an answer to a question. Steps. Creating an Azure OpenAI resource within your Azure subscription. This involves provisioning the necessary compute resources and setting up the required configurations. Obtaining the unique API key associated with your Azure OpenAI resource. which is needed to authenticate requests to the service. Initializing a client library to interact with the Azure OpenAI service. This library provides methods for sending requests and receiving responses from the model. Sending the prepared prompt to the model through the Azure OpenAI client. Making use of the service endpoint and API key for authentication. Prerequisites. An active Azure subscription. Providing the platform for deploying and managing the Azure OpenAI service. An Azure OpenAI service instance created within your subscription. Providing access to the pre-trained models and resources for interacting with them. Fine-tune parameters. The rate at which the model adjusts its parameters during training. A smaller learning rate may lead to more stable training but may take longer to converge. The number of passes through the entire training dataset the model performs during training. More epochs can improve model performance but may also lead to overfitting. The number of training examples processed together in a single batch during model training. Larger batch sizes can improve training efficiency but may also require more memory. Metrics. A measure of the model's performance on a task. Typically calculated as the percentage of correct predictions on a held-out dataset. A measure of the error made by the model during training. Often indicating how well the model is fitting the data. A lower loss generally suggests better model performance. Visualization plots. A plot depicting the model's training loss over time. Providing insights into the model's learning process and potential overfitting. A matrix visualizing the performance of a classification model by showing the actual and predicted. Class labels. Helping to identify common errors and areas for improvement. Error analysis. A systematic analysis of potential biases in the model's predictions. Revealing whether the model consistently favors certain outputs or groups over others. This might be due to biases in the training data. An assessment of the model's ability to generalize to unseen data. Indicating whether the model is overfitting to the training data or is learning generalizable. Patterns. High variance suggests overfitting. Challenges and fixes. Slow inference time. Caused by the computational complexity of large models. Optimizing the model size by selecting a smaller model or using techniques like pruning to remove less important connections. High cost associated with using large models and performing frequent fine-tuning. Reducing the model size. Utilizing a less computationally expensive model. Or optimizing the training process for efficiency. Model drift. Where the model's performance degrades over time due to changes in the real-world data distribution. Retraining the model frequently on updated datasets to adapt to evolving patterns and maintain accuracy. Inputs. The URL of the Azure OpenAI service endpoint, which specifies the location of the service where the API requests will be sent. The API key for the Azure OpenAI service, used for authentication and authorization to access the service and its functionalities. The name of the specific AI model to be used, such as Text DaVinci 003, which defines the model's capabilities and behavior. The input prompt that is sent to the model, providing the context and instructions for the AI to generate a response. Outputs. The response generated by the AI model, based on the input prompt and model's capabilities. Steps. Obtaining the Azure OpenAI service endpoint URL and the API key, necessary for accessing the service and making requests. Preparing the prompt that will be sent to the model. Ensuring it's well formatted and conveys the desired instructions for the AI to generate a response. Sending the request to the Azure OpenAI service endpoint using the obtained API key, along with the prepared prompt, to trigger the AI model's processing. Receiving the response from the model. which contains the generated output based on the prompt and the model's capabilities. Prerequisites. An Azure subscription is required to access and utilize Azure services, including the Azure OpenAI service. An Azure OpenAI resource needs to be provisioned within your Azure subscription to provide access to the AI models and their functionalities. Fine-tune parameters. Temperature parameter controls the creativity and randomness of the generated text. Higher temperature values increase randomness and can lead to more creative and unpredictable results. Max tokens parameter specifies the maximum number of tokens that the model can generate in a single response. This helps control the length of the output. Top P parameter controls the diversity of the generated text. Lower values restrict the model to use more common and predictable words, while higher values allow for a wider range of possibilities and potential for more unique and diverse responses. Metrics. Response time refers to the time taken by the AI model to process the request and generate the response, often measured in milliseconds or seconds. Model accuracy represents how well the model's output aligns with the intended outcome and the quality of the generated text. It is often evaluated based on human assessment or specific metrics like factual correctness, coherence, and fluency. Visualization plots. Response time distribution visualizes the distribution of response times across multiple requests, helping identify trends and potential bottlenecks. Model accuracy over time tracks the evolution of the model's accuracy across different requests or over time, providing insights into the model's performance and potential improvements. Error analysis. Error logs document any errors or exceptions encountered during the process of sending requests and receiving responses, providing valuable debugging information for troubleshooting. API response status codes indicate the success or failure of the API request, providing insight into the underlying causes of any errors or issues encountered. Challenges and fixes. An invalid API key might be the cause of an error while accessing the Azure OpenAI service. To fix this, verify that the API key is correct, not expired, and has the necessary permissions to access the specified service. An invalid model name might occur if the model name is incorrect or unavailable within the specified Azure OpenAI resource. To address this, ensure the model name is correctly spelled and is available within the designated resource. Rate limiting. Where the number of API requests is exceeding the defined limits, can lead to errors. Increasing the rate limit or optimizing the request frequency by reducing unnecessary requests or batching them together can help mitigate this issue. Prompt issues, such as poorly formatted or ambiguous prompts, can lead to incorrect or unexpected responses from the AI model. Ensuring that the prompt is well structured, clear, and unambiguous can help improve the quality of the generated text. Inputs description. The URL of the Azure OpenAI API endpoint to which requests are sent. An API key used for authentication with the Azure OpenAI service. The name of the Azure OpenAI deployment that houses the chosen language model. A text string containing the user's input or question for the language model. For example, what is the capital of France? Outputs description. The text-based response generated by the Azure OpenAI model in response to the input prompt. Steps description. Import necessary libraries like the Azure OpenAI SDK to interact with the API. Create an instance of the Azure OpenAI client using the provided API key and endpoint URL. Send the input prompt to the chosen Azure OpenAI deployment using the client object. Receive the response from the API. Parse it, and process the results for further analysis or display. Prerequisites description. An active Azure subscription is required to access and utilize Azure OpenAI services. An Azure OpenAI resource needs to be provisioned within your subscription to host language models. A deployment should be created within the Azure OpenAI resource, specifying a suitable language model for your use case, e.g., Text DaVinci 003. Fine-tune parameters description. The specific name of the language model used for generating responses, e.g., Text DaVinci 003. A dataset of text and corresponding labels used for training the language model to perform specific tasks or improve its accuracy for a particular domain. For example, a dataset of customer reviews and their associated sentiment, positive, negative, neutral. Metrics description. The time taken by the Azure OpenAI model to generate a response, measured from the moment the prompt is sent until the response is received. A measure of the quality or accuracy of the language model's responses. This could be assessed through human evaluation, benchmark datasets, or other metrics relevant to the specific task. For example, in a chatbot scenario, model accuracy could be measured based on how well the chatbot understands and responds to user queries. Visualization plots description. A histogram visualization depicting the distribution of response times for multiple requests to the Azure OpenAI API. A scatter plot showing the relationship between model accuracy and other factors like the size of the training data, model parameters, or prompt complexity. Error analysis description. Analysis of any errors encountered during communication with the Azure OpenAI API, such as network issues, API rate limits, or authentication failures. Analysis of errors related to the model's performance, such as incorrect or irrelevant responses, biases in the model's output, or difficulties in understanding certain input prompts. Challenges and fixes description. API rate limiting occurs when exceeding the allowed number of API requests within a specified time window. Implement a more efficient rate limiter to control the frequency of requests and avoid hitting the rate limit. Model performance degradation might occur due to insufficient training data, outdated models, or evolving user needs. Retrain the model with a larger and more diverse dataset, or update to a newer model version to improve performance. Prompt design issues can lead to ambiguous or irrelevant responses from the model. Refine the prompt to be more specific. Provide context, or include examples to guide the model towards generating more accurate and relevant outputs. Azure OpenAI response details. Inputs. Azure OpenAI service and data. This refers to the data and services provided by Azure OpenAI, which includes pre-trained models, APIs, and tools for building and deploying custom AI applications. Azure Cognitive Services. This encompasses a collection of cloud-based AI services offered by Microsoft Azure, such as computer vision, natural language processing, speech recognition, and more. These services can be integrated into applications to enhance functionality and user experiences. Outputs. Personalized AI models. These are machine learning models specifically tailored to the unique requirements and data of a particular user or organization. They are trained on domain-specific data to provide customized predictions, classifications, or insights. For instance, a personalized AI model could be used to predict customer churn based on historical data for a specific business. Enhanced business insights. This refers to the actionable insights derived from the analysis of data using AI models. These insights can help organizations make better decisions, improve efficiency, and gain a competitive advantage. Examples include predicting market trends, identifying customer preferences, or optimizing resource allocation. Steps. Configure Azure OpenAI service. This involves setting up the Azure OpenAI service in your Azure subscription and configuring the necessary resources, such as storage accounts and compute instances, to support your AI workloads. Fine-tune model with domain data. Fine-tuning a pre-trained AI model using domain-specific data involves adapting the model's parameters to better understand and perform well on the specific tasks and data it is intended for. For example, a language model could be fine-tuned on medical texts to improve its ability to understand and generate medical-related content. Deploy model for use. This step involves making the trained AI model available for use in applications or systems. This could involve integrating the model into a web service, deploying it as a container, or embedding it within an application. Prerequisites. Azure subscription. This is a necessary requirement to access and use the Azure OpenAI service in other Azure resources. It provides a platform for managing and deploying your AI applications. Azure OpenAI service. This is the core service provided by Azure that offers a range of pre-trained AI models, APIs, and tools for building and deploying custom AI solutions. Fine-tune parameters. Learning rate. This is a parameter that controls the step size during the training process. It determines how much the model's parameters are adjusted based on the training data. A higher learning rate can lead to faster training but may also result in instability. A lower learning rate can lead to more stable training but may take longer. Epochs. An epoch refers to one complete pass through the entire training data set during model training. Multiple epochs are typically needed to ensure the model learns effectively from the data. The number of epochs is a parameter that can be adjusted to control the training duration and pay. Model's performance. Metrics. Accuracy. This metric measures the model's ability to correctly predict the outcomes or classifications for a given dataset. It is a common metric used to evaluate the overall performance of a machine learning model. Precision. Precision measures the model's ability to correctly identify positive instances, true positives, while avoiding false positives. It is particularly important in scenarios where minimizing false alarms or misclassifications is critical. For instance, in a medical diagnosis system, high precision is crucial to minimize the risk of misdiagnosing a serious condition. Visualization plots. Loss curve. This plot visualizes the model's training loss over time. It shows how the model's error rate changes as it learns from the training data. A decreasing loss curve indicates that the model is learning effectively. Confusion matrix. This table summarizes the model's performance by showing the number of true positives, true negatives, false positives, and false negatives for each class. It provides a visual representation of the model's accuracy and how it is able to distinguish between different classes. Error analysis. Model bias. This refers to the systematic error in a model that can arise due to biases in training data or the model's design. It can lead to unfair or inaccurate predictions for certain groups or individuals. For instance, a model trained on historical data that reflects existing societal biases may perpetuate those biases in its predictions. Data imbalance. This occurs when the classes in a training dataset are not equally represented. This can lead to models that are biased towards the majority class and perform poorly on minority class. For example, a dataset on loan approvals may be imbalanced if there are more approvals than rejections. This can result in a model that is overly confident in approving loans, even for high-risk borrowers. Challenges and fixes. Data preparation. This involves the process of preparing the data used for training and evaluating AI models. It includes tasks such as data cleansing, pre-processing, and feature engineering. Data cleansing and pre-processing. This step involves removing errors, inconsistencies, or irrelevant data from the dataset. It also includes tasks like converting data types, handling missing values, and normalizing data to improve the model's performance. Model performance. This refers to the model's ability to make accurate predictions or classifications based on the training data. Hyperparameter tuning. This involves adjusting the parameters of the model during training to optimize its performance. Adjust learning rate. Fine-tuning. The learning rate can significantly impact the model's training speed and stability. A well-chosen learning rate allows the model to converge quickly without overfitting the training data. Increase epochs. Increasing the number of epochs can improve the model's accuracy, but it can also lead to overfitting. Finding the optimal number of epochs is crucial for achieving a balance between accuracy and generalization. Deployment issues. This refers to the challenges encountered when deploying and using trained AI models in real-world applications. Ensure proper infrastructure. This involves setting up the necessary hardware and software resources to support the model's deployment and execution. Scale resources. As the demand for AI applications grows, it's essential to scale the resources to meet the increasing workload. This may involve using cloud-based infrastructure to provide elastic scaling capabilities. Optimize network configuration. Proper network configuration is vital for seamless communication between different components of the AI system and to ensure efficient data transfer and model execution. Inputs. An instance of Azure OpenAI service, which provides access to powerful language models for tasks like text generation, translation, and summarization. Text data that needs to be processed by the Azure OpenAI service. This could be any type of text, such as articles, emails, or social media posts. Outputs. Processed text, which could be the output of tasks like text generation, translation, or summarization. This output is generated by the Azure OpenAI service based on the provided input text. Insights and analysis derived from the processed text. These insights can provide valuable information about the text, such as sentiment, topics, or key entities. Steps. Load the Azure OpenAI service instance, which establishes a connection to the service and allows for interaction with the language models. Prepare the text data, including cleaning, formatting, and potentially pre-processing steps like tokenization or stemming. Send the prepared text data to the Azure OpenAI service, where it is processed by the selected language model. Receive the processed text from the Azure OpenAI service, which could include generated text, translated text, or a summary of the input text. Analyze and interpret the results, understanding the meaning of the processed text and extracting relevant information from it. Generate insights based on the analysis of the processed text, potentially identifying trends, key themes, or other valuable information. Prerequisites. An Azure subscription is needed to access the Azure OpenAI service. It allows users to create resources and manage their Azure environment. An instance of Azure OpenAI service, which is a specific resource within Azure that provides access to language models and their capabilities. Fine-tune parameters. The type of language model to use for processing the text. Different models are specialized for different tasks, such as text generation, translation, or summarization. For example, if you need to generate creative text, you might choose a model designed for creative writing. The temperature parameter controls the randomness of the model's output. Higher temperatures result in more creative and unpredictable outputs, while lower temperatures produce more predictable and consistent outputs. For example, if you want to translate text, you might choose a lower temperature to ensure more accurate translations. The top K parameter controls the number of possible outputs that the model considers during text generation. A higher value for top K allows the model to explore a wider range of possibilities, potentially leading to more diverse and interesting outputs. For example, if you need to generate multiple creative writing options, you might choose a higher value for top K to explore a wider range of possibilities. Metrics: the accuracy of the model's predictions, which measures how well the model's outputs match the expected results. For example, if the model is tasked with classifying text into different categories, accuracy would measure how many texts were correctly classified. The precision of the model's predictions, which measures the proportion of correct predictions among all positive predictions made by the model. For example, if the model is tasked with identifying specific entities in text, precision would measure how many identified entities were actually correct. The recall of the model's predictions, which measures the proportion of correctly identified positive cases among all actual positive cases. For example, if the model is tasked with identifying specific entities in text, recall would measure how many actual entities were correctly identified by the model. Visualization plots. Text summarization plots, which visually represent the main themes and topics covered in the processed text. These plots can help users quickly understand the key takeaways from the text without needing to read through it in detail. For example, a text summarization plot might show the frequency of different keywords used in the text. Sentiment analysis plots, which visually represent the sentiment expressed in the processed text. These plots can help users understand the overall sentiment of the text, whether it is positive, negative, or neutral. For example, a sentiment analysis plot might show the percentage of positive, negative, and neutral sentiments expressed in the text. Error analysis. Input data errors, which occur when the text data provided to the Azure OpenAI service is incomplete, incorrect, or poorly formatted. For example, if the input text contains spelling errors or inconsistent formatting, it could lead to incorrect outputs from the language model. Model prediction errors, which occur when the language model makes incorrect predictions based on the input text. These errors can be caused by a variety of factors, such as the limitations of the model, the complexity of the task, or the quality of the input data. For example, if the model is tasked with translating text, it might make incorrect translations if the input text contains unfamiliar words or phrases. Challenges and fixes. Insufficient training data, which can lead to the language model making inaccurate predictions or generating low-quality outputs. This problem can be addressed by increasing the volume of training data or by using data augmentation techniques to create more diverse training examples. For example, you could use data augmentation techniques to create synthetic text examples that are similar to the real data but with slightly different variations. Model bias, which can occur when the language model learns biases from the training data. This bias can lead to the model generating unfair or discriminatory outputs. To address this challenge, it is important to fine-tune the model with balanced data that represents a variety of perspectives and viewpoints. For example, if you are using a language model for translation, it is important to ensure that the training data includes translations from a variety of languages. and cultures. Limited model capacity, which can occur when the language model is not powerful enough to handle complex tasks or large amounts of data. This can be addressed by using larger or specialized models that are better suited to the task at hand. For example, if you are working with a large corpus of text, you might need to use a model that is specifically designed for handling large amounts of data. Inputs. The Azure OpenAI service is a cloud-based service that provides access to powerful language models, enabling developers to build applications that understand and generate human-like text. Azure Resource Group is a logical container in Azure that enables you to manage related Azure resources. It is essential to create a resource group for managing your Azure OpenAI resources. Outputs. A fine-tuned Azure OpenAI model is a customized language model trained on specific data to perform a particular task. It is more accurate and efficient than the standard model for specific applications. Steps. Creating an Azure OpenAI resource involves setting up an Azure OpenAI service instance and configuring it with the desired language model. Preparing training data involves collecting, cleaning, and formatting data that aligns with the desired task and language model. Uploading data to Azure Blob Storage ensures efficient access and storage of the training data for the fine-tuning process. Fine-tuning the Azure OpenAI model involves training the model on the prepared data, adjusting its parameters to improve its performance on the specific task. Prerequisites. An Azure subscription provides access to the Azure Cloud Platform, enabling you to create and manage Azure resources, including the Azure OpenAI service. Enabling the Azure OpenAI service on your Azure subscription allows you to access and utilize the Azure OpenAI service for fine-tuning language models. Fine-tune parameters. Learning rate is a parameter that determines the step size for adjusting the model's weights during the training process. Epochs define the number of passes through the training data during the fine-tuning process, impacting the model's convergence and performance. Metrics. Loss measures the difference between the model's predictions and the actual values during training. Accuracy reflects the model's ability to correctly predict the desired output based on the input data. Visualization plots. Loss vs epochs plot helps visualize the training process, showing how the loss value changes over the training epochs, indicating the model's convergence. Accuracy vs epochs plot visualizes the training process, showcasing the model's accuracy over the training epochs, providing insights into the model's performance improvement. Error analysis. Model underfitting occurs when the model is not sufficiently complex to capture the patterns in the training data, resulting in poor performance. Model overfitting happens when the model learns the training data too well, leading to poor generalization and performance on unseen data. Challenges and fixes. Data preparation issues can arise from inconsistencies or improper formatting in the training data, impacting the model's learning process. Using an appropriate data format, such as JSON or CSV, is crucial. Fine-tuning failure can result from various factors, including improper hyperparameter settings or inadequate training data. Adjusting hyperparameters, such as learning rate and epochs, can significantly impact the fine-tuning process and the model's performance. Description of the steps involved in displaying Azure OpenAI output. 1. Prepare data. Format data as per Azure OpenAI API requirements. For example, if you are using the Text DaVinci 003 model for text generation, you would need to format your input text as a string. 2. API call. Make an API call to the Azure OpenAI service. You can use the Azure OpenAI SDK or a REST API client to make the call. 3. Response handling: pass the response and extract relevant information. This could involve extracting the generated text, the model's confidence score, or any other relevant information. 4. Visualization: use libraries like Matplotlib or Seaborn for visualization. This could involve creating plots of the generated text, the model's confidence score, or any other relevant information. 5. Error analysis: analyze the output for potential errors or biases. This could involve checking for factual errors, biases, or inconsistencies in the generated text. 6. Interpretation: interpret the results and draw conclusions. This could involve analyzing the generated text to understand the model's capabilities and limitations, and drawing conclusions about the effectiveness of the model. Description of the inputs. Input data in a structured format suitable for the chosen model. The input data should be formatted in a way that is compatible with the chosen Azure OpenAI model. For example, if you are using the Text DaVinci 003 model for text generation, you would need to input your text as a string. Model-specific parameters such as temperature, top P, etc. Model-specific parameters are used to control the behavior of the model. For example, the temperature parameter controls the creativity of the model, while the top P parameter controls the diversity of the generated text. Description of the outputs. Model-generated text summaries, translations, or code. The output of the Azure OpenAI model will depend on the chosen model and the input data. For example, the Text DaVinci 003 model can generate text, translate languages, and write different kinds of creative content. Metrics like perplexity, accuracy, and other relevant evaluations. These metrics are used to evaluate the performance of the model. For example, perplexity measures the model's ability to predict the next word in a sequence, while accuracy measures the model's ability to correctly classify data. Description of the prerequisites. Azure subscription with access to Azure OpenAI service. You need an Azure subscription with access to the Azure OpenAI service in order to use Azure OpenAI models. An Azure OpenAI resource with a deployed model. You need an Azure OpenAI resource with a deployed model in order to use the model. Description of the fine-tune parameters. Learning rate, batch size, and epochs. For fine-tuning, these parameters are used to control the training process of the model. The learning rate determines how quickly the model learns. The batch size determines the number of samples used to update the model's parameters. And the number of epochs determines the number of times the training data is processed. Loss function and optimizer used for fine-tuning. The loss function measures the difference between the model's predictions and the actual values, while the optimizer is used to update the model's parameters based on the loss function. Description of the metrics. Perplexity, accuracy, F1 score, and other relevant metrics. These metrics are used to evaluate the performance of the model. For example, perplexity measures the model's ability to predict the next word in a sequence, while accuracy measures the model's ability to correctly classify data. Metrics specific to the chosen model's capabilities. These metrics are specific to the capabilities of the chosen model. For example, if you are using a language translation model, you might want to evaluate the model's translation accuracy. Description of the visualization plots. Interactive plots to visualize the model's output. These plots can be used to visualize the generated text, the model's confidence score, or any other relevant information. For example, you might create a plot of the generated text, with different colors representing different levels of confidence. Plots to show model performance over time. These plots can be used to track the model's performance over time. For example, You might create a plot of the model's accuracy over time, or a plot of the model's loss over time. Description of the error analysis. Identify biases and potential errors in the output. This could involve checking for factual errors, biases, or inconsistencies in the generated text. For example, you might check the generated text for any instances of gender bias or racial bias. Analyze model performance on different subsets of data. This could involve evaluating the model's performance on different subsets of data to see if there are any patterns in the errors. For example, you might evaluate the model's performance on different types of text, or on different languages. Description of the challenges and fixes. Challenge 1. Input data quality issues. If the input data is of poor quality, the model's output may also be of poor quality. For example, if the input text contains spelling errors or grammatical errors, the generated text may also contain these errors. Fixes to challenge 1. Data cleaning and preprocessing. You can address this challenge by cleaning and preprocessing the input data. This could involve removing irrelevant information, correcting spelling and grammatical errors, and converting the data to a format that is compatible with the chosen model. Challenge 2. Model performance limitations. The model may have limitations in its ability to perform certain tasks. For example, the model may not be able to generate text that is as creative or as fluent as a human writer. Fixes to challenge 2. Fine-tuning, model selection or data augmentation. You can address this challenge by fine-tuning the model, selecting a different model, or augmenting the training data. Fine-tuning the model involves training the model on a specific task or domain, while selecting a different model involves choosing a model that is better suited for the task at hand. Data augmentation involves adding more data to the training set to improve the model's performance. Inputs. The Azure OpenAI service is a cloud-based service that provides access to powerful language models for various natural language processing tasks, including text generation, translation, and summarization. The dataset is a collection of data that is used to train and evaluate the Azure OpenAI model. The dataset should be relevant to the target task and include a sufficient number of examples. Outputs. The optimized model is the final Azure OpenAI model that has been fine-tuned and optimized for the target task. It achieves high performance on the given dataset. The performance metrics measure the performance of the optimized model on the target task. These metrics provide insights into the model's accuracy, precision, recall, and other key performance indicators. Steps. Identify target task. Prepare dataset. Choose model. Fine-tune model. Evaluate performance. Optimize hyperparameters. Prerequisites. Azure subscription is required to access and use the Azure OpenAI service. Azure OpenAI resource is a specific instance of the Azure OpenAI service that needs to be created and configured before using it. Fine-tune parameters. Learning rate is a parameter that controls the step size of the optimization algorithm during model training. It determines how quickly the model's parameters are adjusted based on the training data. Epochs represent the number of times the entire training dataset is passed through the model during training. More epochs generally lead to better model performance but can also increase training time. Batch size specifies the number of training examples that are processed together during each iteration of the training process. A larger batch size can speed up training but may require more memory. Metrics. Accuracy is a common metric that measures the proportion of correctly classified examples in the dataset. It represents how well the model is able to predict the correct output. Precision measures the proportion of positive predictions that are actually correct. It is useful for assessing the model's ability to avoid false positives. Recall measures the proportion of actual positive examples that are correctly identified by the model. It is important for evaluating the model's ability to avoid false negatives. F1 score is a harmonic mean of precision and recall. It provides a balanced measure of the model's performance, taking into account both precision and recall. Visualization plots. Loss curve is a plot that shows the value of the loss function over time during model training. It provides insights into the model's learning progress and can be used to identify potential problems, such as overfitting. Confusion matrix is a table that summarizes the model's performance by showing the number of true positives, true negatives, false positives, and false negatives. It helps to visualize the model's classification accuracy and identify potential biases. Error analysis. Misclassified samples are the examples that the model incorrectly classified. Analyzing these samples can help to identify patterns in the model's errors and suggest improvements to the model or the dataset. Bias analysis involves examining the model's predictions to identify any systematic biases that may be present. For example, the model may be more likely to make certain types of errors for certain groups of people or for certain types of text. Identifying and addressing biases is crucial for building fair and ethical AI systems. Challenges and fixes. Data quality issues can significantly impact the performance of the model. This includes issues such as inconsistent data, missing values, and outliers. Clean data involves identifying and removing or correcting errors in the dataset. This can include removing duplicate data, correcting spelling errors, and handling missing values appropriately. Handle missing values refers to the process of dealing with missing data in the dataset. This can involve removing data points with missing values, replacing missing values with estimated values, or using algorithms that can handle missing data. Model overfitting occurs when the model learns the training data too well and fails to generalize to new data. This results in poor performance on unseen data. Regularization is a technique used to prevent overfitting by adding a penalty term to the model's loss function. This penalty term discourages the model from becoming too complex and learning the noise in the training data. Early stopping is another technique for preventing overfitting. It involves stopping the training process before the model has fully converged. This is done by monitoring the model's performance on a validation set and stopping training when the performance on the validation set starts to decrease. Model underfitting occurs when the model is not complex enough to learn the patterns in the training data. This results in poor performance on both the training data and unseen data. Increase model complexity involves using a more complex model with more parameters or layers. This can help the model learn more complex patterns in the data. Add more data can also help to improve the model's performance by providing more examples for the model to learn from. This can help the model generalize better to new data. Computational constraints can limit the size and complexity of the model that can be used. This can result in longer training times or lower model performance. Optimize code involves identifying and fixing inefficiencies in the code that is used to train and evaluate the model. This can help to reduce training time and improve the model's performance. Use GPU resources can significantly speed up the training process. GPUs are specialized processors that are designed for parallel computing and can handle the heavy computations involved in training large language models. A detailed description of the process for selecting and optimizing Azure OpenAI models, focusing on achieving high performance while maintaining cost efficiency. Inputs. The specific requirements of the task that the OpenAI model is intended to perform. such as text generation, translation, or question answering. Detailed characteristics of the dataset used for training and evaluating the model, including its size, structure, and the distribution of data points. Outputs. The best suited Azure OpenAI model for the given task and dataset based on factors like accuracy, latency, and cost. A comprehensive evaluation of the chosen model's performance, using metrics like accuracy, precision, recall, and F1 score. Steps. Clearly defining the goals and desired outcomes of the task. Outlining specific performance targets and criteria for success. Thoroughly analyzing the dataset's properties, including its size, structure, data distribution, and potential biases. This helps in selecting models that are well suited to the data characteristics. Evaluating various Azure OpenAI models. Assessing their performance on the given task and dataset using metrics like accuracy, precision, recall, and F1 score. This step might involve comparing models with different architectures and sizes. Fine-tuning the chosen model using techniques like hyperparameter optimization to achieve the best possible performance on the specific task and dataset. Deploying the trained and fine-tuned model into a production environment and continuously monitoring its performance, ensuring it meets the defined objectives and adapting it as needed. Prerequisites. An active Azure subscription, which provides access to Azure services and resources, including Azure OpenAI, an active Azure OpenAI service instance, allowing the use of Azure OpenAI models within the Azure environment. Fine-tune parameters. The learning rate is a parameter that controls the step size during model training. It determines how much the model adjusts its weights based on the training data. Finding the optimal learning rate is crucial for effective model training. Epochs represent the number of complete passes through the training dataset during the model training process. Each epoch allows the model to learn from the entire dataset multiple times, potentially improving its accuracy. Choosing the right number of epochs is essential to avoid overfitting or underfitting the model. Metrics. Accuracy measures the overall correctness of the model's predictions, reflecting the proportion of correctly classified data points. It is a fundamental metric used to assess the model's overall performance. Precision quantifies the accuracy of positive predictions made by the model, indicating the proportion of correctly identified positive cases out of all cases predicted as positive. It is particularly relevant for tasks where false positives are undesirable. Recall measures the model's ability to capture all positive cases, indicating the proportion of correctly identified positive cases out of all actual positive cases. It is important for scenarios where missing positive instances is critical. F1 score provides a harmonic mean of precision and recall, offering a balanced measure of a model's performance when considering both false positives and false negatives. It is a valuable metric for tasks where both precision and recall are important. Visualization plots. Model performance curves depict the evolution of the model's performance during training, showcasing the model's improvement or degradation over time. They provide insights into the model's learning process and potential areas for optimization. Confusion matrices visually represent the model's classification accuracy across different categories, highlighting the misclassifications between classes. They aid in identifying potential biases or areas where the model struggles to differentiate between categories. Error analysis. Identifying misclassifications involves examining the model's incorrect predictions and understanding why the model made those errors. This analysis helps identify potential biases, data quality issues, or limitations in the model's capabilities. Analyzing error patterns aims to identify recurring mistakes made by the model, revealing patterns of misclassifications that can be addressed through model improvements or data augmentation. Challenges and fixes. Challenge 1. Model underfitting occurs when the model is too simple to capture the complexities in the data, leading to low accuracy and poor generalization to new data. Fixes to challenge 1. Increasing model complexity involves using models with more parameters or layers, allowing them to learn more intricate patterns in the data. Tuning hyperparameters refers to adjusting various parameters during model training, such as learning rate or regularization strength, to optimize the model's performance and prevent underfitting. Challenge 2. Model overfitting occurs when the model learns the training data too well, leading to excellent performance on the training set but poor generalization to new data. Fixes to challenge 2. Regularization techniques introduce penalties for model complexity, preventing the model from relying too heavily on specific features and improving its generalization. Capabilities. Early stopping is a technique that halts training before the model overfits, preventing the model from memorizing the training data and improving its ability to generalize. Challenge 3. Limited computational resources can hinder the training and deployment of complex models, leading to slower training times and potentially impacting performance. Fixes to challenge 3. Optimizing model size involves reducing the number of parameters in the model, potentially sacrificing some accuracy but improving training speed and resource efficiency. Reducing training data involves selectively removing data points from the training set to reduce the computational load, potentially impacting accuracy but improving training efficiency. Challenge 4. High latency can negatively impact user experience, especially in real-time applications where quick responses are crucial. Fixes to challenge 4. Optimizing model deployment involves choosing efficient deployment configurations and optimizing the inference process to reduce latency. Using caching mechanisms involves storing frequently used model outputs to reduce the need for repeated calculations, leading to faster response times. Implement robust error handling mechanisms within your Azure applications to ensure resilience and reliable operation. Properly handle exceptions and gracefully recover from failures to maintain service availability and user experience. Inputs. Azure resources such as virtual machines, storage accounts, and databases that are used by the application. The source code of the application that needs to handle errors. Outputs. Error logs that record details of the errors encountered during application execution. Notifications such as emails or SMS alerts sent to designated recipients when errors occur. Steps. Identify potential error scenarios by analyzing the application code, understanding the dependencies on Azure resources, and anticipating potential issues that could arise during execution. Implement error handling logic using appropriate techniques such as try-catch blocks, exception handling mechanisms, and error codes. Log and monitor errors using Azure logging services like Azure Monitor to collect and analyze error data. This allows for identifying trends, patterns, and potential root causes of errors. Implement recovery mechanisms to mitigate the impact of errors and restore the application to a functional state. These can include retrying failed operations, rolling back transactions, or using redundant resources to ensure availability. Prerequisites. A basic understanding of Azure services, including their capabilities, limitations, and best practices for error handling. Familiarity with error handling concepts and practices commonly employed in software development. Fine-tune parameters. The error logging level determines the granularity of information captured in error logs. It can range from basic error messages to detailed stack traces and context. Recovery strategies specify how the application should respond to different types of errors. This could include retrying operations, using alternative resources, or gracefully degrading service functionality. Metrics. The number of errors provides an overall indication of the application's stability and reliability. A high number of errors suggests potential issues that require investigation and resolution. Error resolution time measures the duration it takes to identify, diagnose, and fix errors. This metric helps assess the efficiency of the error handling process and the timeliness of addressing issues. Visualization plots. Error trends over time allow for visual analysis of error patterns, identifying spikes, periodic occurrences, and potential correlations with external factors. Error distribution by resource provides insights into which Azure services or resources are most prone to errors. This can help prioritize investigation and remediation efforts. Error analysis. Analyze error logs for patterns in recurring error messages to identify potential common causes and troubleshoot effectively. Identify root causes of errors by investigating the context surrounding the error, including application code, resource configurations, and external factors that could have contributed. Challenges and fixes. Unhandled exceptions occur when the application encounters unexpected events that are not explicitly handled. Use try-catch blocks in the application code to catch and handle exceptions gracefully, preventing application crashes and ensuring continued operation. Network connectivity issues can arise when the application cannot communicate with Azure resources or external services. Implement retry logic in the application code to attempt operations multiple times if connectivity is interrupted. This strategy can increase the resilience of the application by allowing it to recover from temporary network disruptions. Resource availability issues can occur when Azure resources, such as virtual machines or databases, become unavailable due to infrastructure failures or planned maintenance. Use resource health monitoring tools provided by Azure to track the availability and performance of Azure resources. This allows for proactive identification of potential issues and the implementation of appropriate mitigation measures. Data integrity problems occur when data is corrupted or inconsistent, leading to incorrect results or unexpected application behavior. Validate input and output data at various points in the application code to ensure data consistency and integrity. This includes checking for valid data formats, verifying data types, and performing data validation against defined rules. Authorization failures occur when users or applications lack the necessary permissions to access resources or perform operations. Implement proper authentication and authorization mechanisms in the application to ensure that only authorized users or applications can access sensitive data and resources. This typically involves using Azure Active Directory Azure AD for identity and access management. Inputs. Azure OpenAI API key, the unique key for authenticating with Azure OpenAI service. Azure OpenAI resource endpoint, the endpoint URL of the Azure OpenAI resource. Azure OpenAI deployment name, the name of the Azure OpenAI deployment that will be used for making requests. Request data, the input data to be sent to the Azure OpenAI service. This can include text, code, or other data formats. Outputs. Response data, the output data returned by the Azure OpenAI service. This can include text, code, or other data formats. API call logs of all requests sent to the Azure OpenAI service. These logs can be used for debugging and monitoring purposes. Steps: establish connection with Azure OpenAI service. Establishing a secure connection with the Azure OpenAI service using the provided API key and resource endpoint. Send request to Azure OpenAI service. Sending the request data to the Azure OpenAI service using PAY. Selected deployment. Receive response from Azure OpenAI service. Receiving the response data from the Azure OpenAI service. Log request and response data. Logging the request and response data for future reference. Analysis and debugging. Prerequisites: Azure subscription with Azure OpenAI resource. An active Azure subscription with an Azure OpenAI resource created. Azure OpenAI deployment. A deployed Azure OpenAI model, such as text generation, translation, or code completion. Fine-tune parameters. Fine-tuning data that will be used to fine-tune the Azure OpenAI model for specific tasks. Hyperparameter settings that control the fine-tuning process, such as learning rate, batch size, and epochs. Metrics. Accuracy. The ability of the Azure OpenAI model to generate accurate and relevant responses. Latency. The time it takes for the Azure OpenAI service to process a request and return a response. Cost. The cost associated with using the Azure OpenAI service, which depends on the number of API calls made. Visualization plots. Accuracy over time. A visualization of the model's accuracy over time, showing how the model's performance improves with fine-tuning. Latency distribution. A visualization of the latency distribution, showing the average time it takes for the model to process requests. Error analysis. API call errors. Errors that occur during the communication with the Azure OpenAI service. Model inference errors. Errors that occur during the model's processing of the input data. Challenges and fixes. Challenge 1. API key not found. The provided Azure OpenAI API key is not valid or cannot be found in the Azure OpenAI service. Fixes to challenge 1. Verify Azure OpenAI API key. Check if the provided Azure OpenAI API key is correct and has not expired. Verify Azure OpenAI resource endpoint. Ensure that the resource endpoint is correct and corresponds to the Azure OpenAI service where the API key is registered. Verify Azure OpenAI deployment name. Confirm that the deployment name is valid and corresponds to an existing Azure OpenAI model. Challenge 2. Network connectivity issues. The connection between the client and PAY Azure OpenAI service is disrupted or blocked. Fixes to challenge 2. Check network connectivity. Verify that the network connection is active and there is no network outage. Verify firewall rules. Ensure that the network firewall rules do not block communication with PAY Azure OpenAI service. Challenge 3. Model inference errors. The Azure OpenAI model encounters errors during the processing of the input data. Fixes to challenge 3. Review input data. Check if the input data is valid and meets the requirements of the Azure OpenAI model. Check model health. Verify that the Azure OpenAI model is healthy and functioning properly. Adjust model parameters. Modify the model's parameters or settings to improve its performance and address the errors. Challenge 4. Logging configuration errors. Errors occur when configuring or using the logging system for Azure OpenAI requests and responses. Fixes to challenge 4. Configure logging settings. Ensure that the logging settings are properly configured and the logging destination is accessible. Verify logging destination. Check if the logging destination is correctly specified and the logging data is being successfully written to the desired location. Inputs. Azure OpenAI Service Name: the unique name of the Azure OpenAI service within your Azure subscription. This name identifies the service instance where your Azure OpenAI deployments reside. Azure OpenAI deployment name: the specific Azure OpenAI deployment you want to monitor. This is the deployment of a particular model, such as GPT-3 or Codex, within your Azure OpenAI service. Outputs. Usage metrics: this output represents the collected usage data for the specified Azure OpenAI deployment. It provides insights into the consumption of tokens, API calls, and other relevant metrics. Steps. Configure Azure Monitor: this step involves setting up Azure Monitor to track usage metrics for a selected Azure OpenAI deployment. This includes defining the metrics to be collected and the desired aggregation intervals, e.g., hourly, daily. Enable metrics collection: once Azure Monitor is configured, you need to enable the collection of usage metrics for the targeted Azure OpenAI deployment. This ensures that the monitoring system actively gathers data about your deployment's resource usage. Visualize metrics data: after collecting usage data, you can use Azure Monitor's visualization tools to create graphs, charts, and dashboards to display the insights gained from the collected metrics. This helps in understanding usage patterns, identifying potential bottlenecks, and optimizing resource allocation. Prerequisites. Azure subscription: this refers to an active Azure subscription, which serves as the foundational platform for hosting your Azure OpenAI resources. You need an Azure subscription to create and manage Azure OpenAI services. Azure OpenAI resource: this prerequisite refers to an existing Azure OpenAI resource. This means you must have already created an Azure OpenAI service and deployed at least one model within your subscription. Fine-tune parameters. Resource group: this parameter represents the grouping mechanism used in Azure for managing and organizing related resources. It's a container that holds your Azure OpenAI service and related components within your subscription. Subscription ID: this parameter identifies your specific Azure subscription. It's a unique identifier that allows you to manage and access all your Azure resources, including Azure OpenAI services. Metrics. Total tokens consumed: this metric reflects the cumulative count of tokens consumed by your Azure OpenAI deployment during a specific time period. Tokens represent the units used by AI models to process text or generate responses. So this metric provides an indication of your deployment's processing workload. API calls per minute: this metric measures the frequency of API calls made to your Azure OpenAI deployment per minute. It provides insight into the rate of requests being processed by your deployment, which can be useful for understanding user interaction patterns or identifying potential performance bottlenecks. Visualization plots. Time series chart: this type of chart is commonly used to visualize data points collected over a period of time. In the context of Azure OpenAI usage monitoring, a time series chart could be used to display the evolution of metrics like total tokens consumed or API calls per minute over a defined time frame. Error analysis. Unexpected token usage: this error analysis category focuses on situations where the Azure OpenAI deployment consumes an unexpected or excessive number of tokens. This could arise from factors such as overly complex prompts, inefficient model choices, or unusual user interaction patterns. API call failures: this error category addresses instances where API calls made to your Azure OpenAI deployment fail to complete successfully. This could be caused by network issues, service outages, or configuration errors. Challenges and fixes. Challenge 1. High token consumption. This challenge represents a scenario where your Azure OpenAI deployment consumes a significant number of tokens, potentially leading to increased costs or performance issues. Optimize model choice. Choosing the right AI model for your specific task is crucial for efficient token usage. Some models might be better suited for certain tasks than others, and selecting the most appropriate model can significantly reduce token consumption. Reduce prompt length. The length and complexity of your prompts can have a direct impact on token consumption. By crafting concise and well-structured prompts, you can minimize the number of tokens required for each interaction with the model. Challenge 2. API call throttling. This challenge refers to situations where the Azure OpenAI service limits the rate at which API calls can be made to your deployment. This throttling mechanism is designed to prevent overloading the service and to ensure fair resource allocation for all users. Increase service quota. If you experience API call throttling due to exceeding your service quota, you can consider increasing the quota allocated to your Azure OpenAI service. This will allow for a higher rate of API calls, potentially alleviating the throttling issue. Implement rate limiting to mitigate potential throttling and optimize your application's performance. You can implement rate limiting mechanisms within your own application code. This involves setting limits on the number of API calls your application can make within a certain time period. This YAML document outlines the steps: inputs, outputs, prerequisites, fine-tuning parameters, metrics, visualization plots, error analysis, and challenges and fixes related to securely accessing Azure OpenAI service through Azure. Inputs: a valid Azure subscription that has been granted access to the Azure OpenAI service. This subscription should have the necessary resources allocated to support the intended usage of the Azure OpenAI models. An Azure Active Directory Azure AD user account with appropriate permissions to access and interact with the Azure OpenAI service. This user account should be assigned the necessary roles within Azure AD to ensure secure and authorized access to the service. Outputs: the ability to securely interact with and utilize Azure OpenAI models through the Azure platform. This includes the capability to send requests to the models, receive responses, and process the generated content in a secure and reliable manner. The assurance that sensitive data processed by the Azure OpenAI models is handled securely. This involves ensuring that data is encrypted during transit and at rest, and that access to the data is restricted to authorized personnel. Steps: configure Azure Active Directory Azure AD access for the Azure OpenAI service. This involves establishing a secure connection between the Azure AD environment and the Azure OpenAI service, ensuring that only authorized users and applications can access the service. Use Azure AD tokens to authenticate with the Azure OpenAI service. This involves obtaining a secure access token from Azure AD and presenting it to the Azure OpenAI service as proof of identity and authorization. This token-based authentication ensures secure and controlled access to the service. Prerequisites: an active Azure subscription, which serves as the platform for deploying and managing the Azure OpenAI service. This subscription should be provisioned with the necessary resources, such as virtual machines or containers, to support the Azure OpenAI service deployment. A deployed instance of the Azure OpenAI service within the Azure environment. This deployment involves selecting the desired Azure OpenAI models, configuring the service settings, and ensuring that the necessary resources are allocated for optimal performance. Fine-tune parameters. Configure the Azure AD authentication settings to control how users authenticate with the Azure OpenAI service. This includes specifying the authentication methods, access control policies, and any other security measures to ensure secure and reliable access. Implement appropriate network security configurations to restrict access to the Azure OpenAI service. This involves setting up firewalls, network security groups, and other network security measures to prevent unauthorized access and protect the service from malicious attacks. Metrics. Measure the time taken to authenticate with the Azure OpenAI service using Azure AD. This metric helps identify potential performance bottlenecks and optimize the authentication process for faster response times. Evaluate the overhead associated with data encryption and decryption processes during PAY. Interaction with Azure OpenAI models. This metric provides insight into the impact of encryption on data processing times and helps optimize the encryption algorithms for improved performance. Visualization plots. Visualize the success rate of authentication attempts using Azure AD to access the Azure OpenAI service. This plot helps identify trends in authentication failures and provides insights into potential security vulnerabilities or configuration issues. Plot the time taken to process data using the Azure OpenAI models. This visualization helps understand the overall performance of the service and identify potential areas for optimization to enhance data processing efficiency. Error analysis. Analyze instances of authentication failures, such as incorrect credentials, expired tokens, or network connectivity issues, to identify the root causes and implement corrective measures. Investigate occurrences of data encryption errors, such as decryption failures or corrupted data, to determine the source of the errors and implement appropriate solutions to ensure secure and reliable data processing. Challenges and fixes. Challenge 1. Incorrectly configured Azure AD integration settings can prevent users from accessing the Azure OpenAI service. This may involve misconfigured authentication policies, incorrect user permissions, or issues with the Azure AD service itself. Fixes to challenge 1. Thoroughly verify the Azure AD settings related to the Azure OpenAI service, including the authentication policies, user permissions, and any other relevant configuration parameters. Ensure that all settings are correctly configured and aligned with the required security policies. Ensure that the Azure AD user account attempting to access the Azure OpenAI service has the appropriate permissions assigned to it. This may involve assigning the user to specific roles or groups within Azure AD, granting them access to the Azure OpenAI service resources. Challenge 2. Network security restrictions can prevent the Azure OpenAI service from accessing the necessary resources or communicating with external systems. This may involve firewalls blocking specific ports or protocols, or network security groups restricting access to the service. Fixes to challenge 2. Configure firewall rules to allow the necessary network traffic to and from the Azure OpenAI service. This may involve opening specific ports, allowing communication with specific IP addresses, or configuring firewall rules to permit access to the required services. Adjust the network security group settings to allow the Azure OpenAI service to access the necessary resources. This may involve adding inbound and outbound rules to the network security group, allowing the service to connect to external systems and access the required data. This section describes the process of integrating Azure OpenAI within Azure Functions. The goal of this integration is to leverage the AI capabilities of Azure OpenAI within your application, enabling functionalities like text generation, translation, and code completion. Inputs. The input data for the Azure OpenAI model. This can be text, code, or any other supported data format. An example of this would be providing a text prompt for text generation or code for code completion. This refers to the details of your Azure OpenAI resource, specifically its resource name, deployment location, and API key. These are essential for authenticating and accessing the Azure OpenAI service within your Azure function. Outputs. This represents the generated output from the Azure OpenAI model. The format of the output depends on the specific API method used. It could be text, code, or any other desired format, based on the chosen task. For instance, if you use the text completion API, the output will be text generated based on the provided prompt. Steps. This involves creating an Azure Function app within your Azure subscription. The Function app serves as the container for your Azure function code, allowing you to deploy and manage your functions efficiently. The next step involves selecting a suitable trigger for your Azure function. Triggers define how your function is invoked. Common triggers include HTTP triggers triggered by HTTP requests, timer triggers triggered at specific intervals, and queue triggers triggered by messages in an Azure queue. The choice of trigger depends on the specific scenario and how you want your function to be activated. This step involves adding the Azure OpenAI SDK package to your function project. The SDK provides the necessary libraries and tools to interact with the Azure OpenAI service from within your function code. This allows you to make API calls and utilize the various capabilities of Azure OpenAI. After adding the SDK, you need to instantiate an Azure OpenAI client object within your function code. This client object is responsible for making API calls to the Azure OpenAI service. It uses the previously provided resource details, resource name, deployment, and API key for authentication and connection. This step involves calling the appropriate Azure OpenAI API method based on your chosen task. Azure OpenAI offers a range of APIs for different AI tasks. For example, you might use the text completion API for generating text, the translation API for language translation, or the code completion API for completing code snippets. Finally, you need to handle the response from the Azure OpenAI model within your function logic. This involves processing the generated output, extracting relevant information, and potentially integrating it with other parts of your application. For instance, you might store the generated text in a database, display it to the user, or use it as input for further processing. Prerequisites. This requirement involves an active Azure subscription and a deployed Azure OpenAI resource. The Azure OpenAI resource is essential for accessing the AI models and APIs offered by the service. This prerequisite involves having a configured Azure Functions development environment. This environment includes the necessary tools and software for developing, testing, and deploying Azure Functions. Fine-tune parameters. Fine-tuning allows you to adapt the Azure OpenAI model to your specific needs. This involves providing training data that is relevant to your task. For example, if you want to fine-tune a language model for generating summaries of news articles, you would provide a dataset of news articles with corresponding summaries. Hyperparameters are settings that control the fine-tuning process. They influence how the model learns from the training data and can affect the performance and behavior of the fine-tuned model. Examples of hyperparameters include learning rate, batch size, and the number of epochs iterations over the training data. Metrics. Model performance metrics are used to evaluate the accuracy and effectiveness of the Azure OpenAI model. These metrics are calculated on validation data. which is a separate dataset used for assessing the model's performance without being exposed to it. During training, common metrics include accuracy, precision, recall, and F1 score. These metrics measure the model's ability to correctly classify or predict the desired output. These metrics measure the performance of the Azure OpenAI model within the Azure function. Latency refers to the time it takes for the model to generate an output, while throughput measures the number of requests that can be processed per unit of time. These metrics are crucial for understanding how well the model performs in a real-world scenario, especially when considering the limitations of resources and the need for efficient processing. Visualization plots. Plots illustrating model performance metrics over time can provide valuable insights into the model's learning process and how its performance changes with different training configurations. This visualization can be used to identify potential areas for improvement, such as adjusting hyperparameters or adding more training data. Visualizations of the model's generated output can be very helpful for understanding its capabilities and limitations. This can include visual representations of text summarization, code generation, or other AI tasks. By visualizing the outputs, you can assess the model's ability to perform the desired task effectively and identify potential areas for improvement. Error analysis. Error analysis involves investigating and analyzing errors in the Azure OpenAI model output. This helps in identifying patterns in errors and understanding the reasons behind them. Once errors are identified, it is important to pinpoint the potential causes. This can include issues with the input data quality, limitations of the chosen model, or problems with the implementation of the Azure function. By identifying the root causes, you can take appropriate actions to improve the accuracy and reliability of the model's output. Challenges and fixes. One of the challenges you might encounter is handling API rate limits and throttling issues. Azure OpenAI, like many other APIs, imposes limits on the number of requests that can be made within a specific time period. Exceeding these limits can result in throttling, where your requests are slowed down or even blocked. To address this challenge, you can implement retry mechanisms to handle transient errors. Manage API calls efficiently by using techniques like batching or scheduling requests, or consider using a higher tier Azure OpenAI resource, which may offer higher rate limits. Another challenge is debugging and troubleshooting issues related to the Azure OpenAI model behavior. This can involve analyzing the model's output for unexpected results, understanding the reasons behind these results, and taking appropriate actions to correct them. To tackle this challenge, you can leverage Azure OpenAI's error codes and messages for troubleshooting. Review the model's documentation and best practices, and make use of Azure monitoring and logging tools for gathering valuable insights into the model's performance and identifying potential issues. Optimizing Azure OpenAI application performance involves enhancing the efficiency and speed of applications that leverage Azure OpenAI services. This includes minimizing latency, maximizing throughput, and ensuring high accuracy of the AI models. Inputs. Azure OpenAI Service. Application code. Outputs. Optimized application performance. Reduced latency. Steps. Choosing the appropriate Azure OpenAI model is crucial. Selecting a model that balances performance, cost, and accuracy is key. For example, if your application requires fast responses, a smaller and faster model might be preferred, while a larger and more powerful model might be suitable for complex tasks demanding high accuracy. Optimizing application code for efficient interaction with Azure OpenAI services can significantly improve performance. This involves minimizing unnecessary API calls, streamlining data processing, and reducing network overhead. For example, batching requests to the API and using efficient data structures can reduce latency and improve throughput. Using efficient data structures and algorithms within the application code is essential for performance optimization. Employing data structures like dictionaries or hash tables can provide faster access to data compared to lists. Efficient algorithms can further reduce processing time. Minimizing API calls is crucial for performance optimization. By efficiently structuring the application logic, you can reduce the number of requests sent to the Azure OpenAI service, thus decreasing latency and improving throughput. Batching requests and caching responses are common strategies for this. Caching responses from the Azure OpenAI service can significantly reduce latency and improve performance. This involves storing previous API responses and reusing them when the same input is provided, eliminating the need to make redundant calls to the service. Prerequisites: Azure subscription, Azure OpenAI service, fine-tune parameters, model parameters, training data, metrics, latency, throughput, accuracy, visualization plots, latency versus time, throughput versus time, error analysis, identify error types, analyze error causes, challenges and fixes. Challenge 1. High latency can impact user experience and make the application sluggish. Fixes to challenge 1. Use a faster model. Optimize application code. Cache responses. Challenge 2. Low throughput can limit the application's capacity to handle a large number of requests efficiently. Fixes to challenge 2. Use a faster model. Optimize application code. Use multiple instances. Challenge 3. Low accuracy can lead to incorrect results and affect the reliability of the application. Fixes to challenge 3. Fine-tune the model. Use more training data. Improve data quality. A complete description of the YAML file, including the descriptions of each scalar value, for the maintaining Azure OpenAI solution. This is a comprehensive overview of the solution, covering various aspects from inputs to outputs. Steps involved: prerequisites, fine-tuning parameters, metrics for evaluation, visualization plots, error analysis, and potential challenges and their fixes. Inputs: Azure OpenAI Service. The Azure OpenAI Service is a cloud-based service that provides access to powerful language models, such as GPT-3, for various natural language processing tasks. This service is fundamental to the solution, providing the core language models that will be fine-tuned and used for various applications. Training data: the training data used to fine-tune the Azure OpenAI models. This data could be text, code, or any other type of data that aligns with the desired application of the model. For example, if the goal is to generate creative content, the training data could be a corpus of literature, poetry, or scripts. Outputs: fine-tuned model: a customized language model trained on the specific data provided as input. This fine-tuned model will be tailored to the specific task or domain for which it is being trained. For example, a fine-tuned model for generating customer service responses will be trained on a dataset of customer service interactions. Performance metrics: various metrics that measure the performance of the fine-tuned model. These metrics provide insights into the model's effectiveness, efficiency, and accuracy. Examples of common performance metrics include accuracy, recall, precision, inference latency, and loss. Steps: Monitor resource usage, track and analyze the resource usage of the Azure OpenAI service. This step involves monitoring CPU, memory, and network utilization to identify potential bottlenecks or areas of inefficiency. It helps ensure that the service operates within optimal resource constraints and avoids excessive costs. Fine-tune models, the process of adapting the pre-trained Azure OpenAI models to the specific requirements of a particular task or domain. This involves training the model on the input training data, adjusting its parameters to improve performance on the desired tasks. For example, fine-tuning a GPT-3 model for generating product descriptions would involve training it on a dataset of product descriptions. Identify and resolve issues, proactively detect and address potential problems that might arise during the operation of the Azure OpenAI solution. This could include identifying errors in the model's output, debugging issues in the code or configurations, and addressing any unexpected behaviors observed. Prerequisites: Azure subscription. An active Azure subscription is essential to access and use the Azure OpenAI service. This subscription provides access to the resources needed for deploying, managing, and running the Azure OpenAI service. Azure OpenAI service. The Azure OpenAI service itself is a prerequisite for this solution. This service provides the core functionality for accessing and using powerful language models, which are fundamental to the fine-tuning and application of the models. Fine-tune parameters. Learning rate, a key parameter in the fine-tuning process that determines the step size taken during each iteration of training. It controls how much the model's parameters are adjusted based on the training data. A higher learning rate might lead to faster convergence but could also result in overfitting. Epochs, the number of times the entire training dataset is processed during the fine-tuning phase. More epochs generally lead to better training but can also increase the risk of overfitting. The optimal number of epochs depends on the complexity of the model and the size of the training data. Metrics. Model accuracy, a metric that measures how accurately the fine-tuned model predicts or generates desired outputs. This metric is crucial for evaluating the effectiveness of the model in accomplishing its intended purpose. It can be calculated based on the percentage of correct predictions, or by evaluating the model's ability to generate accurate and relevant outputs. Inference latency. This metric measures the time it takes for the model to process an input and generate an output. Lower latency indicates a faster and more responsive model. It is an important consideration for applications where real-time responses are crucial, such as chatbots or interactive systems. Visualization plots. Loss curve, a visual representation of the training process that plots the model's loss function over time. The loss function quantifies the error between the model's predictions and the actual values. The loss curve can help identify patterns in the training process, such as convergence or overfitting. Confusion matrix, a visual representation of the model's performance on classification tasks. It shows the number of correct and incorrect predictions for each class label, providing insights into the model's ability to distinguish between different categories. Error analysis. Model bias, potential bias in the model's predictions due to biases present in the training data. For example, a model trained on text data with gender stereotypes might exhibit biased predictions. Identifying and mitigating model bias is crucial for ensuring fair and ethical applications of AI. Data quality issues. Issues with the quality of the training data can significantly impact the performance of the fine-tuned model. These issues could include missing data, inconsistencies, errors, or inadequate coverage. Addressing data quality issues is essential for producing a reliable and robust model. Challenges and fixes. Challenge 1. High resource consumption. The Azure OpenAI service might consume a significant amount of resources, potentially leading to high costs. High resource consumption can be caused by factors such as model size, complexity, or the volume of data being processed. Optimize model parameters. Carefully adjusting the model's parameters during fine-tuning can significantly impact resource usage. Techniques like model pruning or quantization can reduce model size without significantly affecting performance. Reduce data size. Exploring ways to reduce the size of the training data without sacrificing its quality can help optimize resource usage. Techniques like data sampling or data augmentation can be employed to create smaller datasets while preserving the essential information. Challenge 2. Model performance degradation. The fine-tuned model's performance may degrade over time due to various factors such as changes in the data distribution, the emergence of new trends, or the need for improved accuracy. Retrain model. Regularly retraining the model with updated data helps adapt to changes in pay environment and maintain high performance. This process involves retraining the model using the latest data, potentially adjusting the training parameters for optimal results. Improve data quality. Enhancing the quality of the training data can significantly improve pay model's performance. This could involve addressing data quality issues, ensuring data consistency, and expanding the data coverage to encompass a broader range of scenarios. Inputs. The existing Azure OpenAI resource, which is an Azure resource created for using OpenAI services like GPT-3 or DAL-E. The latest version of the Azure OpenAI SDK, which provides the latest features and improvements for interacting with the Azure OpenAI service. Outputs. The upgraded Azure OpenAI resource after the SDK upgrade is complete and includes all the latest features and improvements of the new SDK. The updated codebase that now uses the latest Azure OpenAI SDK version to interact with the Azure OpenAI service. Steps. Identify the current version of the Azure OpenAI SDK used in the existing codebase. This can be done by checking the import statements in Pay code. Download the latest version of the Azure OpenAI SDK from the official Azure OpenAI SDK repository or package manager. Install the newly downloaded Azure OpenAI SDK version into the project's environment. This can be done using pip or other package managers. Update the code to use the new Azure OpenAI SDK version. This might involve making changes to import statements, API calls, and handling of new or updated parameters and responses. Test the updated code thoroughly to ensure that it works correctly with the new Azure OpenAI SDK version. This can include running unit tests and integration tests to verify functionality. Deploy the updated code to the production environment after ensuring that all tests are passed and the new SDK is integrated seamlessly. Prerequisites. An existing Azure OpenAI resource that has been created and configured to access OpenAI services. An active Azure subscription that provides the necessary resources and access to the Azure OpenAI service. A Python environment that has the necessary dependencies and tools for working with the Azure OpenAI SDK. Fine-tune parameters. Fine-tune model parameters that allow users to adjust the training process of the OpenAI model to improve its performance on specific tasks. Data preprocessing techniques that involve cleaning, formatting, and transforming the training data to optimize the model's performance. Metrics. Model accuracy, which measures the model's ability to correctly predict the output based on the given Input. Latency, which measures the time taken by the model to process a request and generate a response. Cost, which reflects the financial expenditure associated with using the Azure OpenAI service and running the model. Visualization plots. Confusion matrix, a visual representation of the model's performance that shows the number of correctly and incorrectly classified predictions. Loss curve, a graphical representation of the model's training process showing how the loss function decreases over time. Error analysis. Identify misclassifications involves analyzing the cases where the model made incorrect predictions. Analyze error patterns involves examining the misclassifications to find common patterns or trends that could indicate issues with the data or the model itself. Challenges and fixes. Challenge 1. Compatibility issues with previous code might arise due to changes in API signatures or functionality between different versions of Azure OpenAI SDK. Fixes to challenge 1. Refactor code to address compatibility issues by updating the code to use the new API signatures and handling any changed functionality. Challenge 2. API endpoint changes might occur in the Azure OpenAI service which could require modifications to the code to connect to the new endpoint. Fixes to challenge 2. Update code to use new API endpoint by adjusting the URL or connection string in the code. Challenge 3. New features in the latest SDK might introduce new capabilities or functionality that can be explored and integrated into the code. Fixes to challenge 3. Explore and implement new features by referring to the documentation and examples provided with the latest Azure OpenAI SDK version. Azure Monitor integrates with Azure OpenAI Service to provide insights and analysis of OpenAI models and deployments. It offers a comprehensive view of model performance, deployment health, and resource utilization, enabling you to optimize your OpenAI applications. Inputs. Azure OpenAI Service deployment details, including information about the deployed models, their configurations, and resource allocation. Azure Monitor Workspace configuration, specifying the workspace where monitoring data will be stored and analyzed. Outputs. Model performance metrics, such as inference latency, accuracy, precision, and other relevant measures. Deployment health and usage data, providing insights into the health and performance of the Azure OpenAI deployment, including resource utilization and potential bottlenecks. Steps. Configure Azure Monitor Workspace. Set up a dedicated workspace for storing and analyzing monitoring data from Azure OpenAI deployments. Enable Azure OpenAI Service integration in Azure Monitor. Configure Azure Monitor to collect metrics and logs from Azure OpenAI deployments. Define monitoring alerts. Establish thresholds and conditions to trigger alerts when key metrics deviate from expected performance, indicating potential issues or areas for improvement. Prerequisites. Azure OpenAI Service deployment. You must have a deployed Azure OpenAI Service with models ready for monitoring. Azure Monitor Workspace. A configured and accessible Azure Monitor Workspace is required to store and analyze monitoring data. Fine-tune parameters. Model performance metrics. Fine-tune the monitoring configuration to collect and track specific model performance metrics that are crucial for your application. Deployment health and usage data. Adjust the monitoring parameters to focus on specific aspects of deployment health and resource utilization that are relevant to your environment. Metrics. Model inference latency. Measure the time taken for the model to process requests and generate responses. Model accuracy and precision. Assess the quality of the model's outputs by comparing them to expected outcomes. Deployment resource utilization monitor the consumption of resources such as CPU, memory, and network bandwidth by the deployment. Visualization plots. Model performance over time. Visualize the evolution of model performance metrics like accuracy and latency over time. Deployment resource usage patterns. Analyze resource utilization patterns for the deployment to identify potential bottlenecks and optimize resource allocation. Error analysis. Identify model errors. Investigate the causes of model errors and predict their impact on application performance. Analyze deployment failures. Analyze the root causes of deployment failures and implement solutions to prevent recurrence. Challenges and fixes. Challenge 1. Data volume and ingestion limitations. Large-scale OpenAI deployments can generate significant volumes of data, potentially exceeding the capacity of Azure Monitor's data ingestion pipeline. Optimize data sampling and aggregation. Implement techniques to reduce the volume of data ingested by Azure Monitor by aggregating metrics and sampling data at appropriate intervals. Utilize Azure Monitor's scaling capabilities. Leverage Azure Monitor's scaling capabilities to handle high volumes of data by provisioning additional resources or utilizing data storage solutions like Azure Log Analytics. Challenge 2. Model performance monitoring. Challenges. Monitoring model performance effectively requires specific metrics and data points that are relevant to the model's functionality and application context. Implement custom metrics for model evaluation. Develop custom metrics that accurately reflect a model's performance in the specific context of your application. Leverage Azure OpenAI's built-in metrics. Utilize the metrics provided by Azure OpenAI to track key aspects of model performance, such as latency, accuracy, and resource utilization.